programmer.com. Today I'm here with
Mr. Aaron Burnath. What's up, you guys? You guys,
from the Python tutorial. And by the way, guys, I want to kind of just
hey,
show
what's
you what
up?
we're going to be working on today. Look at the screen. Yo, Aaron, what are we looking at right now?
This is Robert Downey Jr.'s glorious face with his
Going to be learning real-time face detection with Python. If you are excited, please drop it in the comments below and let us know that you are excited about this. This took us forever to put together. I apologize. We were late today to the stream. We're 45 minutes behind, but we just have to get a lot of things set up for you guys and make sure that you guys get a great experience. Now that we're here, guys, take a look at this. Here is Aaron's face, and it is actually being
What's up?
detected right now, right?
Yeah.
So look at that. He can move around, right? It detects his face with a pretty high level of confidence. And this is all real time, you guys. This is with Python. And today, the biggest thing we want to do for you is show you how you can do this yourself with a few lines of code. And we want to make it as simple as possible because there's so many different places to show you how to do this, but they don't make it simple. Right, Aaron?
Yeah, a lot of the other tutorials, they added a bunch of unnecessary code to get up and working. Like, this is actually a pretty small app, to be honest. There's not that much code, but there's a lot going on behind the scenes. And we're going to build it first because that's the fun part. We're going to get it all going. You guys can have it on your own computer running. You can detect your own face and whatever other embarrassing videos you have of yourself. But then I'm also going to explain it at the end of actually what's going on instead of just like a bunch of like code in your face. I'm going to explain in layman's terms. So it's going to be interesting, a different approach than what you've probably seen before, but it's going to be good, you guys. Excited.
Awesome. Okay, beautiful. We are pumped. So I think at this point, what should we take a look at now, Aaron? Should we go ahead and look at like how the algorithm works?
Yeah. So, first of all, here's the Robert Downey Jr. photo I caught from the internet just to prove that it's what didn't already have the green square.
Yep.
But yeah, I have this little presentation here. So let's just start this up first, just to give you a little debriefing before I jump into the code, you guys.
Yep.
So first thing here. So in a super simplified way, but just to give everybody context, because I know a lot of you guys are beginners. We were all beginners once, me, Qazi, all of us.
Yep.
And I just want to give you a short step-by-step thing of how like face detection actually works with Python. All right. So first step, the first thing you want to do is, of course, this is going to be a machine learning thing. That's really the only way or the most popular way to do this kind of things. You have to train it on what a face actually is. And then from there, then you're able to classify faces down the road. So step one, get a crap load of faces. Clear? Good.
Yeah.
And from there, we actually don't need it to be color. So step two, we're just going to make them all
if you
black
just
and
real
white.
quick go back to step one, I want to highlight what you're saying because you're saying something really awesome there, and I want to make sure everybody truly really understands this, you guys. So this is awesome how Aaron is putting this together for you. Take a look at that. Like, first thing we do is like we give our algorithm we want to give it tons of faces so it knows how to detect a face. So we're just giving a ton of faces. You can see George W. Bush in the middle, and then you can see like there are thousands of faces around it. So that's our first thing that we're doing. Get all of the faces, right? So what are we doing then on step two?
So after you have all the faces, we actually don't need it to be color. The reason being for this is because what defines a face isn't so much the color, it's more so the composition of like this set of pixels. Like, okay, there's two eyes, a nose, and then there's like some reddish or like dark color or lighter color lips, depending on it. Maybe some teeth or something like that. So we get rid of the colors because it hurts the performance of the algorithm, I believe. But the way openCV does it, which we're going to be using it, openCV, if you don't know what openCV is an open source computer vision library that some people put together. I don't know who put it together, but it's called openCV. We're going to be using that. And they have a lot of cool computer vision functions that we can use to build our app. So the first step we're going to do is we're going to turn everything black and white. All of those faces that we had at the beginning here. That's the very first step.
And we turn them black and white because the computer, the only way that algorithm knows how to look at a face is in black and white. So you want to give it that. It's not going to be looking at it in color. So we turn it into what we call grayscale.
Grayscale, that's the word. Yeah. And then from here, once we have all of our black and white images, our face images, we can pump those into the algorithm, and it will eventually learn how to detect faces. So as you can see here, it's detecting all these different faces here, whether you have glasses, open mouth, frowning, smiling, eyes closed, hair. I mean, the hair is all similar here, but you get the idea. If you train it on enough data, it can recognize babies, females, males, even monkeys. So that's pretty much the oversimplified three-step thing. You just get a bunch of faces, you change them to black and white, and then you train it, and then you run your face classification code, and it will find all the faces in your image.
Awesome. So that's a pretty simple three-step formula, right? So step one, just go to step one real quick. Step one, get a crap load of faces. Step two, turn them black and white. Step three, train the algorithm. That's it, guys. It's just simple 3 steps, okay? Hopefully you guys understand that. So again, get lots of faces. 2, turn them black and white. And then 3, just train the freaking algorithm. And now you're good to go. Now it's going to start detecting everything. So like to actually use it, you guys, it's stupid simple. It's like 10 lines of code, and then boom, your webcam is working and everything is working. So like step one, get away from the fear of like what it means to actually use these types of algorithms. First use them, play with them, and then go deeper into the complexity and everything so you can start to understand and make your own models. Wow, we have 664 people live. That is awesome.
What's up? That is awesome. Yeah. Welcome, you guys. Anybody just coming in, we're making a face detector if you came in a little bit late, but yeah. So with that said, this simple 3-step process, let's just jump straight into the code, you guys, okay? Let me give one more quick demo in case there's anybody new.
Aaron, and what I was actually even thinking of, maybe you could have code on the left-hand side. So you could actually like make your code like on the left-hand side. On the right-hand side, you could have the webcam open the entire time. You see what I'm saying?
Yeah, the thing is, the way this is implemented is...
you're gonna have to keep running it. You have to keep running it. Yeah, that's okay. That's okay. No worries. Okay. Let's keep going.
So we'll just keep it this way. The code is big enough for you guys to see, right? I think that's big enough.
And by the way, you guys, if you are enjoying this video, Aaron, open up your face detection again, just so we can see it. Unless you comment that. So guys, if you guys are enjoying this, and if you think this is cool, I think this is so freaking cool that we're doing this with Python right now. Make sure to hit that like button. It's free. It doesn't cost you anything. It helps us get the video out to so many places. So please go down below and like smash that like button. Subscribe to the channel if you want to learn from Aaron, myself, and all of us that we just give you so much value. So please, please, please hit that like button and let's keep it rolling. Piyush says, by the way, Piyush says, read this comment, Aaron. He says, Aaron taught me how to code in Python. Today, I finally completed my Titanic dataset. Thank you.
Titanic dataset? Titanic.
So, probably something he probably learned from you and then went and like applied it on something else. Yo, we have 826
man.
People live.
Right on. I don't know what that means, but it sounds like something I wouldn't understand. So keep that.
That is awesome.
All right, you guys.
Aaron, 826 people live.
826. What's up, you guys? Let me just keep this running. It seems like people keep flooding in. Where's here we go, you guys. Okay, this is what we're building, you guys. Let's just jump into the code. I think we're almost at 1,000, so let's just get started. All right, so let me comment out all the code that is pre-existing here, so we can start from scratch for all you guys. And actually, just all of it. Okay, so the very first thing that we're going to have to do is obviously install openCV. So if you're following along with me, then please install openCV. And you can do that with the command, wait, I got to quit out of this, 1 second. It should be pip if you're on Linux or a Unix system.
Do me a favor, a few things, Aaron, do me a favor. Take your terminal, put it in the middle, 1, and then also hit Command plus multiple times. Hit Command plus just to zoom in. Yep, and make your screen smaller, and then it's easier to see for everybody.
Terrible habit. That's big enough, right?
That's really good. That's really good. So it's easier to see for everybody.
All right, you guys. So the first thing you're gonna want to run is pip install python-opencv. Okay, I've already installed it. Also maybe add headless here. If you're getting errors, this is optional, but like if you're getting weird errors, try running this as well, and it might work. but this dash headless is optional. But point is, install openCV. That's the very first step. Honestly, there's no way I can help you install it. Forget, there's an endless amount of errors you could get, but you're gonna have to probably Google it and look on openCV. So like if you are getting issues, let me just do that. Let's see, openCV installing issues or something. I'll just give like a brief thing. Find a Stack Overflow here, openCV installation problems. You probably come into here and there's no answers on this one. But I mean, point is, yeah, just install openCV and hopefully that command should work for you, the one that we were just looking at here. And once that's installed, then you're pretty much ready to go. All right. So from here, you can come into our code. And the first thing we're going to want to do is simply, well, first, you're going to want to make a face detector.py file, of course. So start with making your first Python file, face detector there. And just to make sure that it's running, let's just do this. This is a little
quick
convention
shout
I
out.
like doing.
Just a real quick shout out to Pratik. He says, today I had an interview and I showed yesterday's project of Amazon Price Detector and I got selected. Holy crap. That is amazing, you guys.
Dang, go Team Jacob.
Yo,
Jacob
we literally built the price detector.
Students.
Exactly. We built the price detector yesterday, you guys, with Jacob. So that is huge. That is awesome. All right, let's keep it going.
Congratulations, dude.
Yeah, that is so
Great.
sick.
All right, you guys. So once you have your Python file created, facedetector.py, then let's just make sure it's working correctly. Okay, so the first thing you're going to want to do is just run well, make sure you're in the right directory. So you want to make sure that the facedetector.py file is in my in the same directory, and then from there, then you can just run Python and run facedetector.py just like that. Okay.
Nice.
And then hit enter. And as you can see, it says code completed here, which is the print statement. So everything is hooked up and working correctly. That's the very first step. And I like, personally, when I'm coding, I like to keep this at the end of my program because then I know that if this shows up, everything in my code ran and no errors popped up. So I leave this at the end. So that's just kind of an Aaron convention that you can adopt if you like. But now that we have openCV installed, the first thing you're going to want to do is actually import that library. So that library is called CV2. This is, I think the 2 just means version 2. It's been CV2 for a long time, but it's called CV2. You have no choice. Just type it in. And from here, go again, and then let's see if we get any errors. Run the same command. And as you can see, it says code completed, which means it ran this and imported the library without any issues because it reached this line. So from here, now we can actually start coding with openCV. So coming back down here, one thing you're going to have to do is, here, actually, let me go here. So openCV, like I mentioned earlier, is a open source computer vision library provided by some people. And they provide a lot of pre-existing code. Of course, it's a library, so they have code that we can use that we're going to be using that we just imported. But they also have some data files for us. So what this is here is actually pre-trained data. So if you look here, there's so Haar Cascade is an algorithm. We'll get into that in a little bit, but just ignore this big scary word. Haar Cascade, and then it might say, this is the one we're going to be using, the frontal face default, because this, they provided us with a bunch of data and they actually trained this on a bunch of face images like the ones I showed you in the presentation before, like this. But they're
basically
black and
that. Yeah, so that data is actually trained on tons and tons of faces, like frontal faces, right? Just like this one.
Hundreds, yeah, like all of these, like
Yep.
all ages, all that kind of stuff. But frontals, you know, so there's no like blockages, there's no side faces.
Yep.
None of that, just front faces.
Yeah.
So from there, they provide all that. So what you're gonna have to do is actually download this. So if you can just go to this URL, okay, github/opencv/tree, blah, 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 and just go to the default, this one, frontalface.default.xml, and download it. It'll be right here, and it's just a big XML file. And all this is basically a machine learning machine. And when you pump an image through all of these numbers, it'll tell us and find if there's a face in the image or not. And as you can see, this goes on forever. So this is actually what was already trained on like thousands of images. So you want to download this because OpenCV provides it for you. Training it yourself is a gargantuan task of its own. So we're not doing that in this video. We're just using what they're providing for us. Maybe we can do that in a future video. But point is, download this from this URL, and then we can continue on from there. So, any comments, Kazi?
Awesome. No, I love it. Basically, guys, to summarize it, all we did so far is literally just downloaded that file. That's it.
Mm-hmm.
So it's really simple. Just Haar Cascade frontal faces, I think default or whatever, and then download it, put it in the same directory that you're in, and that's all we've
Mm-hmm.
really done so far.
And I have mine right here. See, right
Yep.
parallel to here, along with my Robert Downey Jr. photos and stuff. Oops, not this one. So once you have this installed, then we can go and import it into our app. So the first thing is, well, first of all, I called my variable trained face data because it's what the heck it is, and this is the name of the file we just downloaded, an XML file. I actually don't, I think I forget what XML stands for, but it just looks like this with all these tags. From here, you're going to want to call the openCV library and call this function to make a classifier. So all a classifier is, it's a fancy word for detectors. So detector. So we're making a face detector app. A classifier can classify something as a face. That's all it really is. And then Cascade is, again, the algorithm, the Haar Cascade I was talking about. We'll get into that later. Just ignore the scary word. But what we're going to do is we're just going to pass in that training data and create a classifier for this. And since this is the front-facing training data, then this classifier now will be able to detect frontward-facing faces, and that's what we have here. Okay. So as you can see, I'll put a comment here to load some pre-trained data on face frontals from openCV. From there, we can continue to choose an image or a video stream or our webcam, and then we can actually pass that into this classifier and be able to find the location of faces, and then we can put the rectangle around it. And you have to like draw the rectangle on the image or the video, and we'll get to all of that. But moving on, the first thing we're going to do, let's just do the Robert Downey Jr. Photo. I'm just going to copy and paste it just so I don't have to type it out. But I'll go slowly so you guys can type it out yourself. So the first thing we're going to want to do is choose an image to detect the faces in. So mine is the Robert Downey Jr. photo. So the way you do this is you want to call the image read function from openCV. So very simple. The image, you're going to read it in, and it's going to be the photo that I just had of Robert Downey. So that should be this one. Okay. So it's on my desktop here. And once you have that there.
Somebody just donated to us, bro. That is awesome. And
Really?
they were, yeah, hashtag Yo Garage.
Dang, I can buy lunch today. Yes.
Yeah, finally.
Thank you. Appreciate that.
So that's awesome. Thank you so much for that. He's like, please make a Uber or OLA clone app using React Native. So we might not be using React Native, but we're going to be making a bunch of clones with React. So Uber is not on our list yet. We might think about putting it on our list. We are definitely going to be doing TikTok and I think Spotify and stuff like that. And then Uber, we might do it at some point as well.
I'm not sure what OLA is.
Yeah, not sure.
I'll look that up later. But anyways, this is how you import an image into openCV. Okay, so this is actually, I mean, an image is just an array, like a big matrix of a bunch of numbers. You know, pixels are just numbers. So really what this is, you're just reading the image into a big, like double two-dimensional array. So a big image, a bunch of numbers and bits. From there, now we can actually change it to grayscale. So again, let me see if I can actually show this. Yeah, so let's just go one step at a time.
For the Haar Cascade frontal XML file link. So maybe you want to just go to the GitHub real quick and maybe just show the URL, and then they can pause it on there. So just go there and show the URL. So you guys can pause it here and type that in, and then go to it. Okay.
Yeah, maybe we should put it in the description or something. That might help.
Yeah, we'll put it in the description too at some point for sure.
After. Okay, here, and make sure you're downloading the frontal face default, this one. Okay, there's also cat faces and stuff. I mean, you could actually use all these other ones like lower body, upper body, just a profile with face.
Like you can detect smile.
All this stuff.
Cool.
Yeah, just eyes. Yeah, what's cool about this is you can detect anything pretty much. You could detect Coca-Cola cans and stuff, but we're just doing faces. Like the same algorithm works for anything. Like it's very generic and robust.
Russian plate number.
I don't know what that is. Oh, probably like a
car license plate.
Probably a license plate.
Right.
Yeah, like for Russian cars.
Yep.
But anyways, yep. So here again, URL, download this one. Okay.
Mhm.
And once you have that, then we can continue on. So let me just show this image first. So I imported the Robert Downey Jr. image, and so image read, we read it in, and then to show this image, there's another openCV function called image show, im show. And this string here is just going to be the name of the window that pops up, and then this is the image you want to display. So let's just save this and run this to show you that the Robert Downey Jr. stuff is going to pop up. And what is wrong? Oh, I forgot. You also need this thing. Let me just make sure it works first before I explain.
So the wait key basically waits
There we
for
go.
it. Yep. So the wait key, you need it because
Yeah,
guys,
so let me
otherwise it
explain
just
this.
closes instantly. Go ahead.
Yeah, so what this does is it actually pauses the execution of your code. So it will show the image, and then it will continue on to the end of the program, and it'll terminate the program because it got to the last line here, and it's like, okay, I'm done. So it'll open this for a split second, you won't even see it, then it'll close it immediately. So what this means is this will wait until a key is pressed. So you can press any key to continue in the execution. So it gets here and it waits, and it keeps this open so that you can view the image. That's just the way openCV is implemented. I mean, if you like it or hate it, it's just how it is. But once you have that, then you can run the program. And of course, Robert Downey Jr. pops up here in color, just like I said, okay? And of course, you can hit any button on the keyboard. I just hit space bar and it just closes it. And then of course, it says code completed and I'm back to the terminal. So I'll show you step by step as we're going what it looks like. So we'll just keep these two together, okay, at the very bottom. And okay, so we have a Robert Downey Jr. image in here. Next, we are going to, like we said in the presentation, we got to make it black and white because the algorithm that we're going to be using, the Haar Cascade algorithm, the way it's implemented only takes grayscale images because we can still identify faces in grayscale. We don't need the color. I mean, you can do color, but that's a much more complicated. Like if you want to classify like skin color or race or even like actually identify people, that's even more advanced. That's what Facebook does. You know how you can like tag your friends, it automatically knows their face. That's way more, you need way more training data of like one person to do that. So we're not going to be doing that here, but I just want to mention that. So
Aaron, one real quick side note. What can they do if they want to learn not only these types of skills, but also learn how to make an income with these skills? Where can they go?
Yeah. So if you like coding in Python and you want to learn how to actually make a living from it, so if you want to start coding and landing clients or land a job and just like get your skills and your confidence up and have projects on a portfolio and all those things and really just do this for a living, then we have a course called Profit with Python, formerly called Profitable Programmer. So if you hear either name, they're the same. And the link is in the description if you want to join that.
Yep.
We can actually...
And I'm showing it on the screen, actually. So I don't know if you can
right now.
probably not see my screen, but yeah, I'm showing it on the screen. So guys, the program is called Profit with Python. So in this program, we show you all of these things that you're going to be learning today. You know, whether it's like detecting faces or building e-commerce stores or any kind of project that you can take from Upwork, web scraping, as advanced as you can think it. And then we show you how to actually land those clients. So one of the biggest things we focus on is like, how can you actually earn a killing with Python? That's huge for us. We have dedicated Python success coaches. And really one of the most important things in this program is the fact that you get weekly live Python training calls. Now, Aaron, like, what do you think is a benefit of those like live calls, you know, for the Python like live training calls?
Live training calls, I mean, humans learn live. That's how we've been learning all throughout history. So having somebody there to give you real-time feedback and answer your questions right then and there is like evolutionarily, if that's even a word, the best way to learn. So it's pretty much like you're in a college course, you know, but a cool one because you have a cool teacher and you can show up and do whatever you want. But there's live calls where you build apps together and you can ask all your questions directly to a Python expert.
That's you guys Jacob, are literally building
full
projects every week. So like Jacob is building an e-commerce store. Like you guys think we're building live projects on our YouTube? Wait till you get inside of the program because there the conversation turns over to you and you are the one building all these projects. And then we're giving you personal video feedback on each of your projects that you build. And we get tons and tons of submissions from people. Like even right now, if I show you guys here, like we have tons of projects that people are sending in that they're building with Python, that they're building, like people are building COVID trackers and all kinds of stuff. So here's an example of a project. Boom. Here's something that was built, and I can switch it up into any different country, and you can see that it pulls the queries, it shows all this data, and people are using these skills to freelance. So if you guys want to learn these skills, you want to be able to make an income with Python, then definitely go and check out in the description below. The program is called Profit with Python, and we would love to see you inside of there.
Yeah. So, because coding's fun, building projects like this is all fun. But I mean, if it's fun, then it's just a hobby. If you can make a living from it, I say why not? Because then you can have your fun and make a living from it and do it more. So that's why we provide these courses. We love helping people like do what they love, being coding, and just live the lifestyle they want instead of slaving away at a job they hate, whether it be like retail or fast food or whatever it is.
Yep.
So that's why we're mentioning that. Optional for you, but definitely there. We would highly recommend it, and just check it out. But continuing on, we're awesome. Talking for a little bit long, man. Let's just keep going.
Go for it.
For the viewers.
Yep.
Where was I? I imported the image. So like I said, we need to make it grayscale because the algorithm requires to be grayscale because it's just easier to only deal with one number on each pixel. The color. It's like on a range from like black to white instead of like there's no RGB in each pixel. It's just one number instead of 3 numbers across red, green, blue channels. So we got to change it to grayscale. So of course, openCV allows us to do that too. And let me just go grab that code down here, and I will just paste it, and you guys can type it out yourself as well. So as I said here in the comment, you must convert it to grayscale. And so I just called the variable grayscaled image because it's the same image but grayscaled, and the function that you want to call is convert color. So opencv.convert color, and then you give it the image you want is the first argument, and then the second one is what kind of conversion you want to do, because this function actually you can do a lot of different things. Why don't we pull up the documentation? I'll just show you a little bit really quick. Convert color, so opencv documentation, and let's just go here. Not this one. This one.
Just looked ugly.
Yeah, it is. I got out of there quick. We just lost 600 people in 10 milliseconds. Where is it? Probably, I guess there's a bunch. Gray, basics, thresholding options. Is this the right documentation? openCV 2.
Okay, once
here
you
we
find
go. Okay, CV2.convert color. Found it.
Awesome.
Yeah. So here, convert color, you have a bunch. So the first one is the source image, which is the Robert Downey Jr. image that we had first. And then there's a bunch of different things you can do. So for us, we're going to be using grayscale, but you can also change, like you can change the gray. You could change color to just the red channel or just the blue channel, or you could like dim the whole thing. Pretty much you can convert the image to whatever you want. There's a bunch of stuff in here. Definitely check out documentation. But just wanted to show you guys that because this is actually where you would find how to do that instead of just like, oh, Aaron told me to type it. No, the documentation has all the information you need. So you can go check it out. You can play with it. But for now, we're just going to do the very simple one, cv2.color, BGR to gray. One caveat or one little quirk to openCV is I'm sure everybody knows what RGB is, red, green, blue. That's how each pixel can like mix those 3 channels colors together and make any color for each pixel. But in openCV, the channels are actually backwards. So instead of RGB, it's BGR. And that was very frustrating when I was first learning it, but just be aware of that. And that's why it's BGR to gray, because it's taking this image and then turning it to gray. So let's just show you what that looks like. So instead of displaying the color image, I'm going to display the grayscale image. Let's go back to our terminal and type in Python facedetector.py again, enter, and voila, we have a grayscaled Robert Downey Jr.
Beautiful.
Looks just as sexy.
That
as
is nice.
In my opinion.
That is nice.
All right, you guys, and then of course any button to quit out, and we are back to our terminal. And now we can continue. So that's pretty simple, straightforward. I'm sure you guys all understand at that point. Again, go check out these different settings. There's a bunch you can do, and of course you could even convert it from gray back to RGB. and it would be considered an RGB. But the thing is, when you lose the color and it's gray, then it actually is just gray. So you won't actually get the color back, but it'll technically be a color image, but it's not actually going to look like it. But I'm getting off topic there. From here, the thing we're going to want to do next is, going back to our little presentation here, is we want to train the algorithm, right? But that already happened. openCV was already able to do that. So all we want to do now is to plug that gray image into our algorithm that we were given by openCV, the XML file we downloaded. And from there, it'll be able to open up all these, or detect all of these faces. So like this is actually one image and it detected all 8. And that's what we're going to be doing next. So let's just quit out of here, go back, and let's just detect faces. So yes, some of you guys are probably like, oh, maybe this is kind of fake. It's just one liner that is detecting all the faces. That is true, but like I said, at the end of this video, I'm actually going to go through the whole algorithm and explain it in layman's terms so that you can actually understand how this is working and why it's working and all of that, because then you'll have a full understanding. And there's no point of coding it yourself if it already exists. So this is actually the better approach, because you can understand it, you can get the result, and that's all you need. Once you have those two things, then you can innovate further and go on and optimize or create your own algorithms for your own problems. So yes, this is just one line to to detect the faces, but I mean, shorter code is better, right, Qazi? Shorter code is better.
Because like, look here.
What was that?
But shorter code is always better, less errors. I hate having a lot of code. I even try to get my functions never to be more than like 4 lines of code, or I'll refactor it.
Yeah, having nice encapsulated code. That's the word for it. Like if your function is just, it does one thing and one tiny thing, then you want to encapsulate it in one thing and keep your code very modular, so you can plug and play functions all over the place. So
says, you guys are amazing. You guys are putting so much effort to make us understand things like Python, and you were doing this at midnight as well. So amazing, you guys. Love you all. Thank you so much, Johnson. We are not doing this at midnight. It's 12
it was
p.m. my
7:30
time
a.m. for me.
Yeah, really early for Aaron. But thank you. We appreciate the support, guys, and thank you for the positivity. That really keeps us going.
Yeah, guys, we wouldn't be doing this if it wasn't for you guys. Like there's no reason. If nobody's watching, then what's the point? So
yeah,
thanks for sticking around and putting up with us.
Yeah.
All right, so here, what's happening here is, before we created our classifier, the trained face data that openCV supplied for us within this XML document that we downloaded, and from there we're going to call a function called detect multiscale. Okay, so this probably sounds a little bit maybe scary, maybe not to others, but all this means is whatever this classifier is, which is a face classifier, since that's what we trained it on, the trained face data, then we want to detect all of the faces with a multi-scale thing. So all that means is no matter the scale of the face, if it gets smaller or bigger, then if it's small or big, then it'll detect it anyways. It's just looking for the overall composition, like the relations of the eyes to the nose to the mouth, whether it's small or up close, or if there's multiple of them, then it just wants to detect all of them. So that's what detect multiscale is too. Why don't I actually pull this up on the documentation as well?
Quick question, Aaron. Prakar says, can we use phone camera for detecting the face in real time?
Phone camera. I mean, you would have to somehow connect your phone camera to your laptop so that you could run openCV on there. I think openCV has mobile support, or to some extent. I've never done openCV on mobile, but they might.
I'll take a look at it.
Do it. Yeah, but you would have to somehow hook up your phone camera. I mean, I'm sure it's possible somehow. I haven't personally done it, but you'd have to hook up your phone camera to your laptop and then pipe that into openCV somehow. Like maybe you make it your default camera. I actually think.
Yeah, I'll take a look at that. You don't have to worry about that, but I'll take a look at it and see if something like that exists. But if you guys do understand how to use it this way, then you'll be able to even use it later for phone camera and things like that.
Yeah, we're focused on teaching a thorough understanding of the basic building blocks, like all-encompassing everything, so that when you learn this, then you're equipped to actually go do your own innovation, implement your own creativity and do those kinds of things, because that's where the real learning happens, and then you can be original. Like, I don't just want to be like, hey, here's this project. It's like, here's the skill. Now you can go do what you want with it.
Awesome. All right, let's keep going.
So let's just open up this detect multi-scale. Here we go, Cascade classifier. And here we go. So detect multi-scale. This one, it basically detects objects of different sizes in the input image. So objects is just faces in our case, because that's what we trained it with. We could have trained it with dogs, we could have trained it with cars, with houses, but in our case, it's faces. And from there, the detected objects are returned as a list of rectangles. So pretty much it just returns the coordinates of those green rectangles. And once we have those coordinates, we're able to actually draw those rectangles on our image. So that's what we're going to be doing next, okay? So from here, detect multi-scale, we feed in the grayscale image, which is a Robert Downey Jr. image. And like we said, this returns the coordinates of the rectangles. So that's why I called it face coordinates, because it'll give us the coordinates of the rectangles surrounding the face. And then from here, once we have these coordinates, it's very simple to just draw rectangles onto the image or the current frame of the video if we're doing a video. And it just runs on every frame. So from here, why don't we actually print out, first of all, we don't need to display Robert Downey Jr. anymore, but why don't we actually print out the coordinates, okay? So face coordinates. Did I spell that correctly? Yeah. And let's just run the code. Okay, so the coordinates of Robert Downey Jr.'s face should be displayed in the terminal.
Mm-hmm.
And
Can you do me a favor? Can you make your terminal like wider? That way your line of code can show on one line instead of wrapping. Perfect.
Yeah, my dirty
Awesome.
coding habits. I've gotten
It's all good.
got bad habits beaten into me, but all right, you guys. So this is the location of Robert Downey's face in the image.
Is it possible, Aaron?
two-
Is it possible to also later show the face coordinates, but with your face with the webcam open, and so then as you move, it like actually prints out the console logs in the terminal?
Yes, actually, yeah.
Okay, so let's do
That's
it like
a cool
that.
idea. Let's do that. Yeah, let's do that once we get to the webcam. But right now we're just
Okay.
focused on getting one single image up and running.
Got it.
So I'll explain this. So what this is, like I said, it returns the coordinates of the face. So all this is the upper left coordinate of the face, and this is the bottom right coordinate. So just a bounding rectangle. That's all it is.
Can you just show it visually? Like, can you open up the Robert Downey Jr.'s photo and then like show what you mean?
Yeah. So like I was saying, of course this is going to be grayscaled within our app right now, but just for demonstration purposes, the face is about right here.
Okay.
So
Yep,
this
that's
307 115 would probably be right around here, the upper left hand of
Got
the face, and then this 336 would be right around here,
The bottom right corner.
bottom right,
Okay.
so that you have a bounding rectangle. And then from here, it's very easy to just actually draw the green box surrounding the face, and that's how it happens. Okay, we're doing
got
all
it.
that manually. We're actually we're finding the location of the face, and then we're drawing the rectangle around the face, and then we're displaying that new image with
Nice.
the rectangle. So that's exactly what's happening with
And the rectangle that we're drawing it from a module in openCV. It lets you draw as well.
Yes.
Got it.
And wait, how do I get rid of...
Yo, Tony, how's it going? Awesome. This is Tony
Escape?
that was actually, yeah, you know him,
Tony
right, Aaron?
Orbis?
Yeah.
Yeah, Tony Orbis. What's up, man?
Yeah, this is awesome.
Dang it, I think my terminal bugged out. Let me just terminate and open a new one.
Cool.
Terminal. And LS desktop. And clear.
Mm-hmm.
And again, Python is going to be face detector.
You're not in that file, I think. You have to go in that file. Why don't you open up your
Oops,
terminal
CD.
in Visual Studio Code?
I could do that. What is
Maybe
it?
just Command J.
Command J.
Yep.
All right, and go to my bash.
You can be in your...
So
Okay, that's
CD
fine.
desktop.
Yeah.
And from here, we can run Python. I think it was face detector. or .py. And there we go.
Awesome.
I actually haven't run it from here. Let's see if it actually displays the image. I haven't actually.
Yo,
Wait.
swipe up. No, no, no. It's running. It's running. So use your 4 fingers to swipe up on your mouse pad, and then it'll and then it'll show. Oh, it doesn't have. Yeah, it's. I thought
No,
it would
it's
visually
the
show
wait
it.
key. It's because I'm printing the coordinates and then the wait key, but it's not displaying something. It's just bugging out. So
Got
we'll
it.
let's just terminate this. This is how you terminate it.
Yeah, just
Kill.
open up a new. Yeah, perfect. You can just open up a new terminal if you want.
Yeah.
Oh,
I'm just gonna stick to this one because then I can, because I like having the full code open, the whole thing
got it.
at one time.
Okay, got it.
So, okay, back to desktop, Python, face detector, .py. Okay, there we go. So from here, then we can continue on. Yeah, the wait key bugged out because there was nothing popping up. There was nothing to close, so nothing to actually capture a key and then continue. But that's not that important. Oh, hello, Qazi.
Hi guys.
And yeah, so those are the coordinates. Now from there, like I said, we want to superimpose a rectangle over the image so that we can display it back. And of course, we want to do it with the color image again. So once we have the coordinate, we can go back to the color image and draw the rectangle on the color image once we get the coordinate from the grayscale image in the algorithm. So let's just comment this out. And the next thing is we're just going to draw rectangles. And of course, if there's multiple faces, then it'll draw rectangles around all of them. So we have a loop. But actually, let's just delete that for now. Let's just start with one rectangle. So to draw a rectangle, this is the function. So openCV again allows us to just call something called rectangle. And what it takes is an image that you want to draw a rectangle on. So of course we want to use our color image originally, the Robert Downey Jr. Then the next one, it takes a tuple of the upper left hand coordinate.
Got it.
This is the lower right hand coordinate. So this x, y, and x, this doesn't work because I had the loop. So let's actually just delete this for now. And like I said, the face coordinates is what we want. So the upper left hand would be whatever face coordinates gives us.
Yeah, so face coordinates gave us like that 305 thing, right? Like 305, 116, whatever we had in the command line earlier for the Robert Downey Jr.'s face.
Yeah, so actually, why don't we
manually run it.
Type that out.
Perfect.
Or just actually just manually put in the numbers just to show you guys that it actually works.
Okay. So I'm just going to show visually what we're doing here. You might not be able to see my screen for a second. Okay, so just hold on, and I'm going to just explain this also visually. All right, guys. So basically, if you guys are with us so far, what Aaron is about to do right now is we're going to have Robert Downey Jr.'s face like this, okay? And I don't know if he's smiling or whatever. And then around this, we're going to draw a rectangle. Now, what we need is the top left. So, Aaron, the 307 and then the 116, do both of those coordinates refer to like
X and Y pixels?
X and Y pixels. Okay. So one is the top. So basically just 2 points, right? One is the top left point and one is the bottom right point.
Yep, that's it.
Okay, so this is going to be, and what are the first two numbers, Aaron? Is it 305, comma 1? What are they? Can you tell me?
307 and 115.
Okay, so guys, that's that point over there, okay? Then we have the second point here, and what are the coordinates for the second point?
336, 336.
Okay, so it's 336, 336. All right, so here are the two tuples. This is tuple 1. This is tuple 2 right over here. And that's how we're going to draw the rectangle around somebody's face. We need those 2 points. Once we get those 2 points, CV2 allows us to actually make a rectangle around the face. Okay, so that's what the line of code that Aaron has, if we go look at his screen right now.
Right here.
Yep, so that's those coordinates that he's referring to.
These right here.
Yep, and that's what we're going to do.
I just hard-coded them in just to show you guys for now.
Exactly. And then I imagine the 0255 or whatever, that's the color. Like it's going to make a green color or something.
I choose green. So this, of course, openCV is backwards. So this is BGR instead of RGB. So if this was 255, this would be blue. If this was 255, this would be red if I zeroed this one out.
Yeah.
But I like green, so I just chose green. But you could even make it
Green.
white. You can make it black.
That's
whatever
fine.
the heck you want.
And what's the last two at the end?
The thickness of the rectangle.
Okay, perfect.
So how thin? That's all it is. So of course, if it's 10, it's going to be really thick. But 2 is a nice thin line.
Awesome. So this is, guys, this is a cartoon way of looking, more cartoony way of looking at it. However, drawn here, you saw Aaron's the one line of code that he has right over there. So now let's go ahead and actually run it.
Got it. So here we have the rectangle being drawn on image, okay, and then down here we have an image show, and here we still have the grayscale image. So all we got to do is just change this back to image, because now image has the green rectangle drawn on it around his face. Let's give it a save. Let's go to the terminal and let's run it. And something is wrong. Might have these backwards.
Yeah, that's trying to think.
Let's just
Yeah,
go to
what-
rectangle documentation. No,
Yeah,
I mean,
what-
like that'll give
what-
us the answer.
What it does is it adds them. So if we actually look at the code that we had earlier, Aaron, the one we commented out or whatever, it's like x plus w and then y plus h. So you want to take
Yeah, it
the
has
x
the width-
coordinate
the width and
exactly.
height.
So you want to take the x coordinate and add the width to it, and then you want to take the y coordinate and add the height to it, and that will give you what you're looking for. So just add the width and add the height, whatever.
Yeah, you're right. I forgot that detail. So this is actually the upper left-hand point. Let's go back to there. Let's confirm that. So whoever developed openCV decided to implement it this way, probably because it was smarter in the long term. Instead of having the top left point and bottom right point, they actually have the top left point and then the width and height of the rectangle, so that you can just add this to these points to get the bottom right point. So I guess equally effective. It's the same data, just in a different way. So actually what this would be 307 plus 336, and that would make sense why it's 336, because it's a square. It's the same number because the width and height of a square is the same. So now let's try it. Now it should run correctly. Back to the terminal. Oops.
Yeah.
And much better.
Nice.
Okay, so that bug was fixed, and there we go. So this is a hard-coded solution.
Is it still true that the top left point is 307 and 115? Is that still true? And then the bottom right point is 336, comma 336?
No, the bottom right point. This is the width and height of the square, because it's a square, so width and height is the same.
So what's the bottom right point then?
That would have to be this point. To get the, I mean, it's just some coordinate math. So 307 is the x location of the top left point. So this is 307 this way.
Okay. And
Right
then the
here,
bottom
307.
bottom right is just 115.
Yeah, and then this is 115. No. You have to come on, Qazi. You gotta add the 336 to the width and the height to this point. And once you add 336, it'll come out here and go down. So that's how you get the rectangle.
Okay. Got it. All
Yeah,
right.
the offset. So from there, we have Robert Downey Jr.'s face. Okay. The problem with this, though, is of course we hard coded it in, so we do not want to do that. Okay. What we do want to do is actually just get the points dynamically and then print those out. So like we just did, it's going to be like this.
Nice.
The thing is, we are going to want to make sure we are getting the coordinates from the face coordinates correctly. So x, y, width, and height, like we said in the terminal. Okay, so this is x, y, width, and height here. And we can do that using a for tuple and just set this equal to face coordinates. Okay, and this will automatically assign each of those four numbers, 1, 2, 3, 4, to these four variables, 1, 2, 3, 4. And now that we have these
nice
in a tuple, then we can just pool those x, y, and the x, y WH out just like this, and this should work unless I got my math wrong again, which could be very possible.
Awesome. We just broke 1,000 likes, I heard, on the video. That is amazing. Thank you, guys. Thank you.
One more value to unpack. Face coordinates. What is the last coordinate? Wait, what was it complaining about? Face in line equals face coordinates. Value error. Need more than
You
one
never
value to unpack.
Oh yeah, you actually did define.
Buggy. Maybe.
Wait, hold on. Isn't it face coordinates of 0 or something? Because it's a array with it's a list within a list. So you might have to like
the double brackets there, right?
Yeah.
I don't know why that is, but yeah, that'll probably work. So let's give this a shot. There we go. Yeah. Oh, I guess that makes sense because it's a list of here. That would make sense because if there's multiple faces, then you want a list of lists.
Yeah.
You would have a second face. Okay, that's why that's like that. That makes sense.
Yeah.
But there you go. There you go, guys. So now we have it dynamically getting the face with the coordinates here.
That is so cool. That is so cool. Can you turn it red real quick? Just like
Sure.
just real quick. Like that's awesome.
So there we go.
Sunny
So
was telling
in
me you have like
GR.
scary amount of knowledge on color.
Oh yeah, I worked at a I had a data science gig for 8 months doing openCV stuff, like exclusively, like 4 years back. So
crap!
I went crazy.
I didn't know that.
Oops. Oops. Oh, I killed the terminal. Alright, you guys gotta
Command T,
start
Command T,
over.
Command T.
Oh my God, no! I murdered it, Qazi.
Nah, that's
I'm
fine.
sorry. Brutally. It's dead.
That is
It's
hilarious.
dead.
Damn.
Oh, wait.
This guys, this is the right person. Keep opening it up, and once you open it up, do let me know. But guys, this is the right person to learn openCV stuff from. Like he just was doing this for almost a whole year.
Yeah, edge detection, motion detection, background. Like you can do a lot of cool stuff. But right now we're just doing face detection. So desktop, and again, let's go Python face detector.
Yo, Aaron, maybe like upcoming few weeks, just like go crazy. Edge detection, like bring all of that back. So yeah, you guys like look at that. We just turned it red, super fast, super
From
easy.
green.
Yeah.
So
Awesome.
you can change the color. I mean, minor detail, but yeah, let's change it back to green because I like green better. And of course, this is the thickness. So let's just do a quick.
Yeah, change it to
That's
real
bad.
thick, like 5 or 10. That would be awesome.
Kaboom!
Nice.
black.
That actually looks great. I like that level of thickness.
Like it? All right, let's keep it then.
Yeah.
So we'll keep that there.
That is so cool. Like we're detecting a face in real time and drawing the circle dynamically around it. And this code already works on any image you give it. That is mind blowing.
You could even have a circle instead of a rectangle.
But
You
it's
can
only
draw a
gonna.
circle.
But right now, it's only gonna draw it on the first person it sees, you guys. So if there are 2 people, it'll only draw it on one person's face. But once we write a loop, it's so cool. We're looping through humans. Like that blows. Like you literally are looping through human beings. That is insane.
Yeah.
It kind of blows my mind. I almost want to take a picture. I almost want to take a picture of us right now and send it. Can I do that? Can I just take a picture of both of us split side by side, and then you open that image up and run it on it, or is that too
Let's
much?
go for it. No, it should work. I
Okay,
mean,
cool.
Yeah, this algorithm isn't 100% accurate. The algorithm, the Haar Cascade algorithm, is more concerned with speed than accuracy, so it might not 100% work, but like 90% it'll work. So let's just
Okay.
try it. Just make sure you have good lighting, and then it should work fine.
Yeah, I got good lighting. Let's detect it right now. So I pulled it from our live stream, and I'm sending it over to you in Slack. So what you can do in the meantime is just go ahead and pop it in to your, like, it's so cool to me. So just go in Slack and then pop it into your image. See what I'm saying? Okay, cool. But like, guys, this is so mind-blowing to me, the fact that you can actually like detect images. So like what I'm talking about, looping through human faces here, right? If I can just draw it out for you guys. So let's go over here and I'm going to draw it out. But let's say that we had, I'm going to clean this up. But let's say the image I gave Aaron has 2 people in it. So if you have actually 2 human beings here like this, right? What we're about to do right now, which is mind-blowing, is for right now, our code, all it's going to do is draw a circle around like one person's face. It's going to decide who, whether it's Aaron or me, and that's it. But then once we write a for loop, it's actually going to make a square around Aaron. So that's person 1. And then it's going to loop through, find me, right? This is Qazi. It's going to find me. And then it's going to make a circle around my face, like a for loop that loops through human beings. That is just cool. Like, that's the power of, being able to actually do like face detection and AI with Python or really any language. Like, it's so freaking cool to me. If you guys think it's cool, go ahead and smash that like button. But to me, it's kind of mind blowing. And then whenever you're ready, Aaron, just let me know.
Got it. Yeah, so I got the picture of me and Qazi here on my desktop, and instead of reading the Robert Downey Jr. photo, I just want to read in this photo. So I just named it Qazi Aaron, okay, and I'm gonna comment.
Is it in the same directory? Okay,
yeah,
cool.
just on my desktop. It's kind of sloppy.
Cool.
I mean, to be
That's
honest,
fine.
but
That's fine.
I just keep it there just to get it up and running.
Can you show the image first? Can you show the image first by itself, so they don't think I sent it to you with green squares around it?
There we go. So this is the image, okay.
Mm-hmm.
I wonder. I think it'll detect my face there.
Yeah, maybe. We'll see.
So that is the image now. We're using that instead.
Yeah.
And from there, we want to detect all the faces. So right now, we only going to detect one. So let's run it and see who it detects first, Aaron or Qazi.
Yeah.
Let's just give it a shot.
Or if it breaks, we'll see. We'll find out.
And hey,
whoa!
looks like it gets me first.
That is so cool.
And for that reason, it probably goes. I think it gets me first because it scans from upper left to bottom.
Yeah,
right.
can you do me a favor and change that index? Like, dude, this is an array of us two, like in one fucking array. Like, I'm sorry, guys, excuse the language, but like, in one list, it's 2 human beings. Can you index that array? Can you index the list with 1? So then it puts me maybe. Let's take a look.
Yeah. So because you're second in the list. So if we did this, then it would.
Oh, dude, this is about to blow my freaking mind right now. I'm so pumped.
Kaboom!
Oh my god, dude, that is cool. Like, that is so cool.
Let's see if there's a 3. Let's see if I got your shirt. Let's see.
Oh, if it got. Oh my god.
Maybe it did.
Yeah, maybe it detects my face. This is so cool. This is so cool. I can't get over it. I cannot get over it. I don't care if people think it's cool or not. I think it's so freaking cool. Oh my god.
Yeah, dude. See, so that's what I was talking about, you guys. When it says multi-scale, what it's doing is it's taking the trained data and it's checking for all sizes. So it's starting big or starting small, and then it's iterating. So it starts with rectangles. It's called a sliding window. So it'll like slide the window all the way across, tiny, did nothing, bing, found a match. Then go a little bit bigger, nothing.
Damn, that is sick. It's an array of 3 items of 3 human beings in a little list. 3 human beings in a list. How does it make you feel? Yo, that is so cool. Like, I'm blown. Like, Logan is like, damn. Paula is like insane.
I know, right? And all we did is copy and paste like 6 lines of code. It's amazing.
It's so crazy. It's 6 lines of code. That's right. People are like, oh, somebody's like, that's actually epic. Dude, can we loop through it and draw the squares around all of us?
I don't know about that, man. I don't know if my skills are up to par for that. But
I mean, we had the loop. You wrote the loop earlier.
Yeah, I'm kidding.
Oh, okay. All right.
Yeah, we got you guys. So now we're just gonna have this be a loop. So we have a list and a list of three faces that we detected in that image, and now we just want to loop over them instead of just doing it one by one. Of course, we could probably do this. This is a sloppy way to do it, but why don't we do it just for sake? So this is actually like running a loop 3 times, but just manually.
Yeah, and it's just listing it out. Okay, got it.
And run it, and kaboom.
Oh man, that is nice. So this is just manually doing it.
Yeah, and let's make this nice and big. Nice thumbnail, you know?
Wow. Oh, that should have been the thumbnail of the video.
Nah, I mean, Robert Downey Jr. is too sexy, man. Or Justin Timberlake.
That's true. You're right.
We're ugly, bro.
Yeah, 6 lines of code, man. Like, that is so cool to me. Even Logan is going. He's like, bro, this is literally input in the 6 lines of code. What the hell?
It'd be cool if you can change the color, you know? Like, you even like label them and stuff. But anyways, let's go back and make this actually loop the proper way. So The way we're gonna do that is
Oh yeah, change. Also, yeah. Once you write the loop, let's also like change the colors between 0 and 255. It just picks randomly, so then it'll be different colors.
oh, that's fun. All right.
Yeah. Okay.
Dude, on the webcam when we're doing the live webcam, it's gonna be like rainbow. It's gonna be like going crazy. It's gonna be pretty cool.
Yeah. 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 Yeah.
But all right, so let me just go on here. So I'm gonna type it out. Here's the loop. All right, and we're just going to replace this top line. This one, we're gonna replace it with this. Okay. So instead of manually getting it here and getting the first face in this list of faces and then assigning it, we're just actually going to loop through all of them. So because this is a list, we can loop over it using the word in. So for this tuple in this list, which means it's going to iterate over everything, then it's going to have the same functionality, okay? So do this, make sure you tab correctly. So for this tuple, x, y, width, height in face coordinates, then this is unchanged, okay? Because we had the variables exactly the same, so this is actually going to work, minus the randomization of the colors. But let's just give this a run and see what happens. And it might even pick up extra stuff if it failed. There might even be like a fourth face somewhere. No, there is none. But there we go, you guys. So this is functioning so far.
Oh, that loop worked?
Yeah, it did.
We're looping through 3 human beings right now?
Well,
Or
I mean,
2 human beings?
Human beings and 1 cartoon.
Man, this is so crazy to me. Wow.
Why do we
Wow.
look so dirty? We have the same glasses, man.
This is awesome. Yo, okay, I got you with the different colors. So Aaron, go all the way to the top of the file and and just do hold on. Import, so do from random, import rand range all the way at the top.
Like that?
Yep. I am. So you misspelled import. Yep. And then where you have that 255, you see where you have 0, 255.
Mm-hmm.
So just do ran range. No. Don't do that. Don't do that. Don't do that. Don't do that. Just the 255. Just wrap the 255 in the function ran range.
Got it. Like
And so now
that, right?
you could do 250, yeah, 256 because it's gonna go up to but not including.
Okay.
Yeah. So now it should be randomly like making the colors. So now if you hit save and run it, everybody should have like a different color. Hopefully, it would be really unlucky if all 3 of them were randomly generated.
It's
to
just
be
well,
all
this is
green.
just the green. This is just the green channel, so it's going to be different scales of green, but not different colors. So it'll
Oh,
be
I
different
see.
shades-
Oh, so
it'll
then you
be
can
different
actually
shades
just
of
do
green.
rand range for all of them. Like for all of the coordinates, you could do. So go back.
Mm-hmm.
You could do for like
Yeah.
for 0, you could do that, and all 3 of them, you could do the same thing.
There we go. And
Yeah.
now let's run it, and now it should be random colors.
Nice. That
Blue,
is so cool.
red, and green.
Damn. Okay. Awesome.
That would be
Sick.
useful for identification. Like if we ever actually trained, if you got enough of your images, enough of my images, and enough of this little shirt, we could actually like train it and be like, okay, Qazi's red, Aaron's blue.
I just
and-
can't get over that we're in a list. We are in a list right now in a Python like that. Okay, dude, I can't get over that. All right, let's keep going.
We know. One thing I do want to try though is I feel like those colors are a little bit dark, but if we keep the range in the upper half of the 256, then they won't be so dull all the time. So let's actually go 128 to 256. Okay.
Oh,
Let's
I
try
see.
this, and then I think the colors will always be brighter.
Color science.
Little. I mean, it kind of looks.
It's fine.
Like ass,
It's fine.
but that's fine.
Yeah. You can remove
we'll
the
put it
one. Yeah, just so it's less confusing for them. But yeah, rand range is awesome, right, guys? It's
Great.
pretty cool. Qazi, Logan goes Qazi 2020. I'm in a list.
You're getting excited. Coronavirus got us all screwed up, you know. Like we're getting excited about a list. Like,
Awesome. Let's.
excited.
All right.
Anyways, let's
Thank you guys. We
continue
just
on,
broke
okay?
1,000 likes. Thank you guys so much. Really appreciate you guys. Our team just notified us. Frankie just notified us like 1,000 likes on this video. Frankie's pumped.
Awesome, you guys. Thanks for all the support. We appreciate it. I don't know how long we've been going for, like almost an hour already, right? This is
Yeah.
going way longer than 1 hour for 6 lines of code.
This
We're
is
the
so
most
fun. This
inefficient
is
team
so
ever.
fun. I think everybody's pumped. I think everybody's totally like, what do you guys think? But I honestly think that everybody's freaking pumped out of their minds because I think this is the
Yeah,
coolest freaking tutorial that's out there on face detection. Everything else is like so boring, dude. Every time I try
absolutely,
to learn it, I go to fucking fall asleep.
absolutely. Wait till I explain actually how it works, like mathematically. Like it's not complicated, but like that'll blow your mind. Because right here we're just calling a piece of code. Anybody can copy and paste this. But if you actually understand how it works, that's the mind-blowing part. So stay tuned to the end for that, okay, guys?
Yeah.
We're almost done. So we're gonna move on to video now because actually our image is done. So have already gotten the image and we're displaying it here. And then
Yeah.
I would display it here. So we display the image here. Display the image with the faces.
Mm-hmm.
And then we have the wait key, of course, which is just waiting until we press a key to close. And once it closes, then code says code completed, and we are done. So, okay, we are detecting faces on a single image, but what if we want to detect faces in a video? Well, all a video is a bunch of images one after another. So we can actually just run this code on every single frame of an image, of a video, I mean, whether it be a video file or our webcam stream. We're going to be using the webcam stream. And that will basically give us real-time face detection. So it's pretty much the same exact code with just a loop added on the outside. So let's do that now, okay? I'm just gonna continue modifying this code. So let's go down here, and the first thing we're gonna have to do is actually, instead of capturing an image, we're gonna want to capture the webcam. So let's start from here. Let's comment out the image, and instead let's paste in this. Okay. So instead of calling image read on an image file to get an image like this, we instead are going to call CV2 video capture. So all video capture means is you're going to capture a video. If you put a 0 in here, it's going to get your default webcam. So for the person asking about your iPhone, if you can make your iPhone the default cam, I think using 0 would actually work. You just have to like specify on your computer system settings.
Unfortunately, I went and checked, and openCV does not
Cannot do it.
work with iOS. But I honestly think that if you figure out how to make this work, you can easily make something with JavaScript and then host it online, and then people can go and use it. But the most important thing is to get experience using it, learn how this technology works, and then you can go and implement it in any language you want on any system.
Absolutely. So, I mean, I think it might be possible. Like, look into it maybe. It won't work natively on the iPhone, but you could use your iPhone camera, hook it up to your computer, and then use your iPhone and look around and have that be in this app. But the point I was saying was, if you have 0, it automatically goes to your default webcam. But if you put a file name in here, then you could have like, video.mp4 or something. If that was on my desktop, it doesn't exist. Well, actually, I do have a video here. Where is it? It was a funny
You can
one.
detect a face. That's actually cool.
LOL memes. So let's
The,
just do this.
oh, nice. I didn't know you could give it a video. That is so nice.
Yeah, you can. Oh, it's actually not going to work because we haven't coded it all out. So let's actually do this later. But first step is calling video capture, which allows you to get the webcam or a video file with the same function, which is nice. So thank you, openCV, for being smart and efficient.
So
But that's
Ahmed
the first thing.
asks, "Where's the training part?" The training part is on line 6. That's where we
The
trained it. That's where we
Yeah,
trained the data. But keep
we
going,
actually
Aaron.
yeah, we actually didn't train openCV because training takes a lot of time. Like we would be sitting here for anywhere from probably like half an hour to multiple days, depending on what kind of data you're training. So that's why we didn't do that here. We stole the trained data that openCV already trained for us like years ago, and then they just supplied this machine learning network for us to use, and we just downloaded that, which is right here. So this is actually the trained data. So all these numbers, the -4, the -2, and all these crazy numbers, if you pump an image through all these crazy numbers, it just filters through and it finds the faces magically. The same way your eye can find a face when you look at a picture, this is doing something remotely similar that your brain is doing, but in a different, like in a computerized way. So that's what this is. So yes, the training is happening in here in essence. Hope that's clear. Kazi? I cannot hear anybody.
No, you're good. You're good to go. Keep going.
Got it. So let's just get this going and then actually display the webcam, okay? I believe we need wait key as well. Yeah, pretty sure we need wait key. And webcam release. Let's see if this works.
And this is awesome. We still have 685 people live. This just tells us we got to be doing a lot more of this, Aaron, because it seems like everybody loves this stuff. Because most of the times by now we drop to like 100 live people watching. This is awesome.
Yeah, people are loving it, right?
Yeah.
Dang.
Okay. Done says, yeah.
Well, it's not going to work because we need the loop. So this is a little bit confusing. So if I were to do this and display what this gave us, it would only give us the first frame. So we're gonna have to kind of do a big chunk of logic together, guys. We're gonna have to code up the whole loop and get it going as one. So just bear with me and we'll get that going. So once you get the webcam here, what you're gonna want to do is get a while loop. Okay, so this loop is going to go right here, and what this does is we just want it to loop over all the frames in the video forever until the video ends or until we kill the webcam. So for the webcam, we just want it to run forever because it's just is real time until we tell it to stop. So that's why we want a while loop running forever. And then from here, now we can actually go and fetch the current frame and display the current frame. So let's go down and get this. So this is the next call. So this is actually how you would get the image out from the video. You could technically run this outside of the loop, but then like I said, it would only get the first frame and it's essentially just an image again, which is kind of the same as what we did before. So I'm just jumping into the loop. So there is this webcam that we made, okay, from the video capture. We called it webcam, and webcam allows you to read from it. So you just call the read function here, and what this returns is two things. Tuples. So the first thing it returns is if the reading the frame was successful or not. This is just a Boolean. It'll be true or false. And then this is the actual image. So the frame that is being read currently from the webcam. This we actually don't need, but we need to be there just to like for placeholder. But we're never going to use this. This should always be true. Okay. But this is all we want. We just want the frame. So once we have the frame, now we can actually take the frame. And instead of frame, use the frame instead of image. So before we're using image with Robert Downey Jr. and everything and being Qazi and all that. But now we just want to actually change the image to frame because this is the image we're using. It's the current frame. So why don't we actually do that? And let's comment this out. And just show the webcam in grayscale. Okay, so we're not going to do any detecting yet. Let's take this, paste that in here, and show this. Okay. Remembered. Yeah. So the one thing about wait key is. Actually, let me demonstrate it first, and I think that'll be better. So let me just run this and see what pops up. I don't think anything's gonna. There we go. So as you can see, this is just a single frame. It's not moving because the wait key is waiting on something, and it got a little bit screwed up. So actually, what we need to do, if I hit an image though, you can see it skips to the next frame. So I can move around, and then when I hit my space bar, then it automatically goes to that frame because it's waiting for the key. So one way to get out of this, I gotta force quit this because there's no way out of it. Force quit Python. There we go. We are going to put a delay in here. So wait key here, if there's nothing in here, it'll wait infinitely until you hit a key for it to quit or to go to the next frame like we did. But if you put a number in here, it'll wait this amount of milliseconds before it automatically hits a key for yourself. So we can wait 1 millisecond, then it'll auto hit a key, which means each frame will be happening every millisecond. So let's try this, all right? And this should actually be live webcam footage in grayscale from our webcam. So as you can see, it's just grayscale. There's no face detection yet or anything. I'm just doing this, and then the wait key every millisecond is just keeps pressing a key every millisecond.
It
Like
already. Wait, so hold on one second. So that's so sick that already has you in grayscale in real time, like from Python. I did not know you could do that. That is so cool. And what are you saying about this 1 millisecond thing? I'm not understanding it. Like, what is it? What is it doing?
It's a little
no,
bit.
no, 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 no.
So,
Just show your screen. Show your camera. So like, okay, so what's happening? Like without it, would it close? Would the window close?
no. So wait key. What wait key does in openCV, the way it's coded, the way it's implemented is, it's going to wait for a key press to execute code. So the code will just wait at wait key. That's why it's called wait key. It's waiting for a key to be pressed.
I'm just
before it
trying to
continues.
understand in English, like what happens if it's not there or you don't do it the right way? Like, does the code break? Like, does the video stop playing? Does the next frame not load? Like, just in pure English, like what is it that it actually does?
Wait key. It's stop. If it's not there, then it just won't work. First of all, but
okay,
what
that's
it's
great.
doing is it's like you need wait key to actually display something. Like you cannot in openCV, the way it's designed is you cannot display something if you don't call wait key.
Okay,
because
that's
you
it.
need
That's
to-
all. That's the most important
what-
thing I care about. Like if I just want to use this, like all that's
Got it.
for me that's really important. So okay, so if I don't have wait key,
Basically,
it won't
this is
display.
display.
Got
This
it.
is display. Yeah, you
Perfect.
can think of it. It's not actually what it is, but that's the behavior that comes from
Okay,
it.
beautiful, beautiful. Got it. Okay.
So yeah, because if it's not here, then it won't work. So let's quit this. Again, you gotta force quit. We'll fix that in a bit, you guys. We'll be able to like hit the Q button and it'll quit instead of having to force quit. But here, if I run this, then I don't think it's gonna work. It'll like pop up for a second or something and then disappear. Yeah, see, it just freezes up and there's nothing. We're here. Yeah, so it gets there and then it gets stuck in an infinite loop. So that's not a good idea. Nothing pops up. You need wait key because you want it to wait here, and you want to show a frame and then wait at that frame. That's what you want it
Got
to do.
it. Okay.
So let's close. See, yeah, Python not responding because we're stuck in this infinite loop with no way to get out. So it just bugged out. All right, continuing on now. So let's put this back. You can think of it as display. But what I was saying was if there's nothing in here, it'll wait forever and wait for you to actually press a button for it to continue to the next iteration of the loop. So if you go back to the code, this is a while loop, right? And it's going to run over and over and over again. And each time it runs, it's getting the current frame and then displaying it in grayscale to the screen. Okay, it's turning it to grayscale and then displaying it with image show right here, the current frame. Then it waits here forever until a key is pressed. So that's why the behavior is weird. It's frozen. It's the current frame. And then when I hit a key, then it goes to the next iteration of the loop. The next one. And if I spam it, then you can see that I'm kind of like moving. But then if I stop, then it breaks. So what wait key does is it waits for a key infinitely. But if you put a number in here, then it'll only wait for that many milliseconds before it automatically just continues on and goes here. So that's why we're saying then I don't have to press any buttons. It'll wait for 1 millisecond, then automatically go to the next iteration, aka the next frame. And so we're getting 1 frame every millisecond. I mean the camera rate will be lower, but that's what it does. So we'll quit out of this again one last time. Force quit this. And run this to get the correct behavior. And there we go. So we're in real time. Every millisecond, the loop is automatically restarting with the wait key because we put a 1 in here. You could even put like 1,000 in here, and then every 10 seconds it would go automatically. So, but we'll leave it at 1 because we want it to be real time. Now, moving on from here, we have the grayscale, but now we want to plug in the face detection into this. So just the same as before, we're going to want to take the detect faces, and of course we want to apply it to the grayscaled frame. So instead of just displaying the grayscale image, we want to find the coordinates of that and then display it, display over it. So the grayscale image, this is all the same code. The face coordinates are going to be using the trained face data, and then of course the detect multiscale, and then we're giving it the grayscale image from right here, just the same as the image. Then we need to draw the rectangle. So this is the same thing again. Let's just steal this loop that we wrote earlier. And and pop it in right there. And this should work as well. So let's just double check. Image, actually this won't work because image was the image before. This actually needs to be frame instead, okay? And I think that is it. It's just the frame has to change. So what we're doing is we're detecting
Oh,
the
I
face.
see. It's pulling the frame, just to be clear, because I got confused at this. I'm sure people are going to get sometimes confused. It's pulling the frame from line 18 when webcam.read unpacks. Okay, cool.
The current frame of this loop, every millisecond, the current frame is called frame. So we want to detect the face in this frame, grayscale, and then we want to draw the rectangle on the frame, not on the Robert Downey image that we had before, but on the current frame of the webcam, because we have webcam now. So that's how that works. Now let's just run this and see how it goes. I think that's everything. So of course we're going to need to force quit this again and go to terminal. And why is it not working? Because I am displaying the grayscale image, not the colored one. 1 second, I must have got a bug somewhere. So yeah, so the image show, it's showing the grayscaled image. What we want to show is actually frame, okay?
Nice.
Because that's the colored frame, going back to color, and then we put the rectangle on top of it. So we want to display that instead of grayscale. So now it should work. But knowing my luck, it probably won't. There we go. And there's the RAN range.
Oh, nice! And the color is changing every second. Look at that. That is so nice.
So you can see, yeah, you can see the 1 millisecond refresh rate. That's actually pretty cool. The color you can see like in real time.
Dude,
actually, you can see every
that
time
is
the
so
loop.
Cool.
Every time the loop iterates, it's getting my face. It's not perfect though, because this is actually a pretty lean algorithm. There's more powerful algorithms, but of course, there's always a trade-off of speed and accuracy whenever you're doing algorithms. For everything in like computer science and data science, there's always multiple algorithms you can use to solve a problem. This one, we're using Haar Cascade specifically because this is the most commonly used one. Like this, like on your little cameras, digital cameras, your iPhone is probably using this.
That's so cool that we're looping through on your face and like drawing, like looping through and making new colors. Like that is just the coolest thing. Damn.
And we're gonna have to force quit this.
Wow.
Okay. And let's continue on. So we can actually get rid of this stuff and keep code completed. So, oh, I forgot one more thing. So I kept having the force quit, which is pretty dang annoying, to be honest. So I threw in this thing earlier today of giving us the ability to, and we got to clean up after too, but being able to actually quit using a key, a specific key. So, wait, did I copy the right one? Yeah, this one. So if I pop this in here, all this means is, oh, first of all, I screwed this up. So actually, when you're getting the wait key, you can actually capture which key was pressed on the keyboard. So it's waiting for a key, and then you can actually get it. So if I don't press a key, then this is probably like 0 or null or something, or none in Python. But if you press a key, then it'll go into this. So what I decided was if you press the Q key, then Q for quit, then it'll quit out. So I looked up the ASCII characters for Q. Very simple. You can just type in ASCII. If you didn't know, every keyboard character has its own ASCII code. ASCII is just ASCII. I don't know what it actually stands for, but every letter has its own number. So if you go to Q, you can see Q is 113, lowercase q is 113, uppercase Q is 81. So 113 and 81, that's where I got these numbers from, 113 and 81. So uppercase or lowercase q will actually break out of this infinite loop. And that allows us to exit the real-time face detection without needing to force quit the way I was doing it all this time. Okay? So let's give this a shot and see what happens. Run it. And it's going good. And let me hit the Q key. Q. Oh, is it connected? Q. Must have had a bug. Let me go double check. What is wrong? Oh yeah, forgot the webcam release. Always forget these things. Good things, like especially when you're doing memory allocation or any kind of like streams of data, you should always clean up your code afterwards. So in this case, you're gonna have to release. So I think this might be the case. Let me see the. Yeah, let's try it again. There we go. Now let's hit Q. I think it's lagging. I think it was actually working, but it's just taking a long time to actually. There we go. Okay, so it was working. I think the color, maybe the random color was doing some stuff. I don't know. It's just being laggy, but pretty much it has the working functionality. I'm actually curious. Let me just try to change this and see if this is actually what is holding it up. And let's run this again. Go here, so it's just green, back to what I had before, and then hit Q. Nope, my computer is just slow. I think it's just bogged down from the live streaming and everything at once. I think that's why it's slow. Really slow. Anyways, it'll close after a few seconds. Not important. Well, let's change this back to the multicolors because that was cool. And that there, guys, is pretty much the completed real-time face detector app. Okay, we have the ability to detect faces in images, to detect faces in webcam, and even video. So actually, let's. I have a video here called LOL memes that you guys have probably seen before, and let's pop this in. So instead of reading from the webcam, we're going to be reading a video file on my desktop.
So if you give it an argument of 0, it reads it from your webcam. But if you give it and if you give it a name, it actually looks for that file path.
It's just capturing video from somewhere. You just gotta tell it where to capture video from.
Awesome.
That's all it's doing. So now let's try to run this, and we can see it work.
Whoa! What is going on? Whoa, that is crazy.
It's getting that guy a little bit. Yeah, you can see it's not perfect.
I mean, it's really difficult. Like, this is a crazy video, and it's already pulling it. Like, that's insane. Wow.
Yeah, so I pulled this video, and you can see it's getting his face at the end there.
People are like, wow, it's amazing. Very nice.
Awesome. And then, of course, if you hit Q, it will quit. That one happened a lot faster.
Can you? Oh, I see. Okay, interesting. I'm trying to think. Okay, cool. Is there any other videos you have on your computer that it can pull from?
Yeah, I have this funny baby that I got.
Okay. Let's see. Yep, right there.
I was testing these earlier.
Nice.
And there's no audio, but here's an.
Oh my god, that is so cute. That is so cute. I love that. I love that.
The dad is basically like tormenting the baby by making them say stuff. But yeah.
Logan says super impressive, Aaron. Logan says super impressive, Aaron. Thank you for the content.
Absolutely. We haven't even gotten to the interesting part yet. This is the fun part, but the interesting part is about to happen. Yeah. So this is working here. Again, I'm going to try capital Q this time, and it should quit. Look at this baby.
Wow, our loop is still working and going through the random colors. I love that.
Yeah, I think we're giving the baby epilepsy. That's what's happening here. He's going crazy.
You know what you can even do is like right next to it, draw random captions, like draw like random, so like how have that people have that like speech thinking bubble next to them.
Yeah, something like that.
So we could even exactly. So you can detect faces and automatically put like speech bubbles in real time next to it that like writes out text.
or Morty, I think we could superimpose
Oh,
our faces. Our
I don't know.
faces.
I don't
So
know about
you
that,
could do
Rick.
that. Yeah, we're thinking of doing that. We're gonna superimpose Rick and Morty's faces over our faces, but it was too hard to do that with the stream at the same time. We couldn't technically figure it out to stream live.
Oh,
But
jeez. I mean, we
you
could
can do that
we could
too.
probably do that, you guys. You would really have to just let us know if that's something you're gonna like. You can go ahead. Oh, jeez, just go ahead and smash that like button. That'll be so awesome.
Yeah, Morty.
All
Tell
right,
him
awesome.
I didn't actually know you had a head on your shoulders, Morty. But I'm proud of you today. But today only.
People are loving it. They're like, this is amazing. They're like, I wish I could code like this.
I still hate you, Morty. You piece of shit.
Logan is laughing.
Yeah, I love Rick and Morty, man. Oh, I love Rick and Morty.
Yeah, awesome.
Anyways, that is that, and that completes the app. But now, I mean, this is a lot of hand wavy woo woo stuff. We just called this detect multiscale and downloaded this file, and then it just kind of magically started detecting faces. Like, cool, like a 5-year-old could have done this, which is true, but which is also awesome because I mean, you got this up and running with like minimal work. But I do
Yeah.
want to give you guys understanding of how the algorithm is actually doing it. Like, how the heck is a computer looking at an image, and how does it know what a face looks like and actually understand it? So that's where I want to actually go to here, okay? So let's just look at this for now. I put together a little presentation to actually transition people over into thinking like a data scientist, because most data scientists are coders, but not all coders are data scientists. Like, you can be a coder, you can be a front-end developer, which is amazing, web developer and stuff, but like if you don't actually understand like some of the underlying algorithms and stuff, you can't actually pursue anything in data science if that's what you want to do. And that's what Python's known for, so that's why I want to touch on it. So instead of being a coder and just like copy pasting what I taught you now, you need to actually understand what's happening behind the scenes, so that in all the little tricks that are happening, so that you can actually innovate on that and continue forward and actually come up with like new and faster and better face detection down the road. So, but you got to understand the basics before. So let's continue on, okay? Face detection. So what the hell is Haar Cascade? That's the big question, because if we go back to the code, then all this stuff was like Haar Cascade, Haar Cascade. What the heck is Haar Cascade? Why does it say Haar Cascade? And we just downloaded this thing. Well, this is just an algorithm, okay? So Haar is the name of a dude who invented the algorithm, and Cascade is just the word cascade. So Cascade is like a chain of events, pretty much, and you're just going down, like you're going down a funnel. So what it's doing is it's going down a funnel until it finds a face at the bottom of the funnel, and then it's like, here's one face, and it keeps doing it over and over again for every face. You're cascading down. That's the one paragraph explanation, but let's actually go to
1 second, Aaron, real quick. If you want to cue me to show your face, just be like, hey, so, camera 1 or something like that, and I'll switch over to your face, or you can just tell me. So right now I have the camera on both of us. So now when you're drawing, like moving your hands physically, it'll show, and now I'll hit 2 and it'll go back to the screen.
Got it. Yeah, well, just show me really quick while I'm explaining it. So, like I was saying, the Haar Cascade is just like a chain of machine learning things that the image is being passed through, and then it's going to funnel it down until it finds the exact square where there's a face. It kind of looks at like every square of every size on the image, and it passes each of those squares through this machine learning thing, and then it cascades down. Eventually it's like, okay, if you pass all of the cascades and you get to the bottom, it's like, okay, this is close enough to a face to actually be considered a face. And that's why it's called Cascade. Haar is just a name. You can kind of ignore that, but hopefully this makes it seem a little less scary. You kind of understand. But now it's time to reveal the magic trick of face detection. Okay, it's pretty mind-blowing.
Awesome.
Like, honestly, I wouldn't have been able to figure this out on my own. Like, these geniuses did it, but I learned it in my schooling at Georgia Tech when I took computer vision, and now I'm just going to share it with you. Okay, so yep, time to reveal the magic trick. Don't be this guy. I have this GIF here. So it's actually pretty simple how it works. And I want you to understand, instead of being like this guy, like, how the hell does face detection work? I want you to just know like how it works, because it actually is this simple. Like, you can see it from the third one. Like, once you understand, it's that simple to understand.
love that. That is awesome. That is hilarious.
Let's continue on.
Yeah.
So as you know, the algorithm is called Haar Cascade. So let's start with Haar. So what Haar Cascade does
You can
is
also, by the way, you can full screen this. You can just hit Command Enter, and it'll full screen it, so everybody can see it in a better way.
yeah, I'm a technique.
And you can actually use the pointer. So at the bottom left, click pointer, and then when you actually move your mouse around, like people, you can actually,
Oh,
yeah. So it's
dang,
easier to know what you're talking about.
dang, okay. See, I'm just a coder. I don't know all this fancy Google slide stuff.
Yeah.
But anyways, so these are Haar features. So this is the first part of the Haar Cascade algorithm. So it's a very, very simple thing. What you can think of Haar features as rudimentary building blocks. So this is one Haar feature. This is another Haar feature. This is another Haar feature. This is one, and this is one. All this really is a little block. So what we're going to be doing is we're going to be placing this over a portion of an image that has a face in it or doesn't have a face in it. And all it's doing is it's kind of showing the relationship from the white portion to the black portion. And then what this allows us to do is it kind of allows us to approximate the relationship of these pixels within this box. So if we overlay this over somebody's face, then we could be like, okay, down here in relation to the pixels up here, there's some kind of relationship. And then, or this way, you could be like, okay, the pixels on the left have some kind of relationship to the pixels on the right. Or like this, you can do the three thing, like, okay, there's a relationship, a three-way here, or a diagonal. And this is like the most elementary ones. Like you don't have to go any bigger because you can just kind of chain them together. But these starting blocks is what you start with. And if you chain these together over and over again and you layer enough, you can actually, some combination of these 5 things will actually give you a template for a face. It'll look like a face, and then that's how they actually find faces, by layering this over and over again and cascading all the way down these different layers, and then actually finding one that matches a face. And the way it does that is you give it faces, so it finds out the combination of these things to know what a face is, and then you can just filter through it again. So that's kind of the idea of Haar features so far. So these are Haar features, and let's continue on to the next slide. I think it'll make more sense when I show this one. So this is how a Haar feature is applied to an image. So like these, let's say these are blank images or background images that have no faces in them. One Haar feature is here, and here's another one, a different type where it has three columns. Another one is here, and as you can see, this is how you would overlay it on an image. So this is the raw image, but then if you have the Haar feature here, what we're looking for here is, the relationship of this black box to this white box. And what's cool is if you look on this face here, you can kind of tell that this rectangle here of his eyes is a little bit darker than his cheeks and his nose. And you see how that corresponds to the black and the white here? So we can actually say that this Haar feature is closer to a face than something else, like placing this like all the way on the bottom left, where it's kind of like not, because there's kind of like a black bar here and a white bar here.
So white, so the white
sense?
one means that is more like a face, and then the area that's black is like that's less like a face.
The black is like, you can think of it as like it being darker, and the white is it being lighter. So you're saying like there's some kind of like going from light to dark in this direction, or dark to light to dark in this direction. So if you see,
so like literal.
A
so
dark
like
bar going to a light bar. You see right here is exactly what this
okay,
Haar
so
feature
one
is
second.
saying.
So basically the face detection, it doesn't look for facial features. It's just looking for like how dark and light it usually is around faces.
And that's why you only need grayscale.
Holy crap. That is
this
crazy.
is only one algorithm. There's a bunch of different ones, but this is the most well known and most widely used.
Like literally just looking at, so for this one specifically, it's just looking at like, yo, here are 100 different faces. Yo, Frankie, bring your face in real quick. So like it's like it'll like have like a certain thing for like dark and light for his face versus a dark and light for
eyes,
it trains them
light
on
cheeks. Yeah.
So then it's just looking for white and black. Like okay, cool.
Like if we went back, like this would even be a better match because you have forehead, then eyes, then cheeks. You see what I mean? If we had that here, you could also have a white bar up here. You can kind of see it's like white, then dark, then white. So we're basically saying there's some kind of 3-layered relationship of this block of pixels, and this is only one layer of Haar cascades. Basically, we're going to layer 1,000 of these little matches together, and eventually those added up will add up to a face.
Wow.
So you can see the second one here. You can kind of see like, okay, the eyes are darker and the bridge of the nose is lighter. See, the eyes are dark and the bridge of the nose is darker. So this
Yep.
Haar feature plus this Haar feature is even closer to what the heck a face is.
Yeah, this is what Logan is saying too. He's like, he goes, this is
Yeah.
why we use grayscale, right, Aaron? And he goes, because
Yeah.
color is irrelevant. We're actually just looking for brightness. Yes, exactly.
Well, you can start using color when you want to get like really like if you want to like profile like race or skin color, or if somebody has freckles or not. You could even start doing that but it would, of course, you would need more data and longer time to train. But this is the most generic case, but I want to teach you guys from the ground up so that you understand how this works, because this is the prerequisite to everything else. Okay.
Yeah.
So this is how a Haar feature is applied to an image. And of course, you would just take this box and you just drag it all the way around the image. You would even resize it, like because again, you could have like this similar thing might be like it might match on the mouth a little bit. But let's move on. Okay. So these are Haar features. These are the 5 rudimentary Haar features, and this is how Haar features are applied to an image. And if it's like this, then there's no match. There's like it's just a white flat background. Or if it was like a landscape or like your wall or something, then there's going to probably be nothing there. But let's go on. There's a little bit more nuances, but that's the general idea so far. So now, actually, how did openCV train that face detector that we downloaded, that XML file? Because that's where the magic is. We just downloaded it and just like called a few lines of code, which is kind of like, okay, cool. But how do they actually do it? Because from here, if you understand it, then you can actually start thinking correctly and do some real data science stuff. Like, you're not a data scientist unless you actually understand the algorithms. So step 1, like we mentioned at the very beginning of the call, you want to start out with your training data. So in machine learning, the way it works is you have positive images and negative images. And all these are just labels. So this would be labeled as face, labeled as face, labeled as face. This would be labeled as not face, not face, not face. That's all it is. You just need faces labeled as faces, and
So
non-faces
just to
labeled as
contrast, just to contrast that, guys. So here is a face, right? But here is like, this would be a negative image, right? A phone would
a
be a
non-face.
non-face. So like, for
anything that's
example,
not a face.
so
It could
again,
be
non-face
cup of
is
coffee, anything.
yep, cup of coffee. This is a non-face when it sees it. This is a face when it sees it, right? And this was through supervised learning. So it fed the data to the Haar Cascade, right? And it told it, yo, these are all faces and these are all non-faces, yeah? So this is so this is called supervised learning. We're probably not going to go too much into unsupervised, supervised, but like at a high level, it's like a human being's telling it what is a face and what isn't, and then it feeding it like lots and lots of data.
Yeah. Another way to explain it, if somebody didn't catch that, is there's 2 fields of machine learning. There's supervised machine learning and unsupervised machine learning, which is what Qazi just said. Supervised means these are all faces and these are all non-faces. It's supervised. You're supervising the actual data, and you can tell it like, these are faces. Okay, that's what a face is. These are not faces. Okay, that's not what a face not is. But if you're doing unsupervised, you're literally just given a bunch of stuff and you have no labels. And then you can just at the end be like, oh, was it right or wrong? So you have even less data. But that also is a lot better, because when you're gathering photos from the real world or data from the real world, usually it's not labeled. You'd have to go in there and manually label it by a human, because how else would you know these are faces? So there's kind of 2 fields of thought. Supervised is better to learn first, but unsupervised gets very, very messy. And it's kind of like the cutting edge right now.
Yeah, that's where like you really get into AI and all that stuff.
Deep neural nets and all that stuff. Deep neural nets.
Awesome.
This is just machine learning. So start out with training your data. So you have a bunch of labeled images, and from here you'll go to the next thing. So after you have all of your images, so we have face images, and then also non-face images, you want to find the winning Haar feature. So like I said, this Haar feature matches nicely with the eyes and the cheek, and then even if we had like the other Haar feature with the lighter bar on the forehead, that would even be a better match. But for this one, we're just using this. This is a fairly good match. And this one is also a good match, okay? So basically what we want to do is we just want to chain together all the Haar features that kind of match and add them together, sum them up until we get a face template. These are like little Lego blocks to like doing it. And this is why it works for nothing, because they're rudimentary building blocks. This can work for a Coca-Cola can. You can distinguish a Coca-Cola can from a Pepsi can eventually, because it looks different, and like the brightness relationships within these boxes and sizes of boxes is all different. That's why you just start with like plain old boxes and you add them up.
Insane that you can tell the difference of everything based on brightness. Like, this is where algorithms are so freaking cool, because
I mean, it's what your brain is doing, right? Like, what is your brain doing? It's doing the
that's
exact
true.
same thing. It recognizes a face versus not a face. And we're just
Yeah.
teaching the computer how to do the same thing.
Dang. Damn.
So it
Wow.
blows your, like, self-driving cars. This is absolutely like essential. Like Tesla, Tesla stock is going up like crazy. Elon Musk just passed Warren Buffett and his net worth as of like 3 days ago. Like, go Elon
Are you
Musk. Elon,
serious?
protect Elon. Yeah, he's 70 billion. Warren Buffett is 69 billion. He just passed.
Whoa.
But Elon Musk is now number 7 in the world. He's exploding, bro. But yeah, the Tesla self-driving cars, they use this heavily. It, like with other things, but there's a lot of computer vision. So like you could detect pedestrians.
Whoa.
Detect
I am
traffic,
showing
detect
that on
stop
my
signs, detect
screen,
traffic
Elon.
lights using the same HAR function.
That is insane. I just I have an ad blocker on, so I have to turn that off real quick. But I'm just showing them on the screen that Elon Musk actually passed. Oh my God, is this website annoying? Holy crap. Jesus Christ. Okay, I'm out of here. They can keep their. We don't need to look at that. Business Insider. Yeah, Elon Musk just passed him officially. That is insane.
Yeah, Elon Musk is my guy, man. Like, Daniel works at Blue Origin, right? That's like the competitor of Elon Musk's SpaceX.
Yeah. Oh
We have
my
a guy here at Clever Programmer who works at the competitor of SpaceX.
Jeff,
right?
yeah, he worked for Jeff Bezos' company, and he works on an actual rocket ship at Clever. He's going to actually be here next week, and he's going to be teaching everybody algorithms and maybe even some stuff with Python.
Yeah, he makes me look like a baby.
Yeah. Awesome. So keep going.
But yes, so after we have all of the images, the face images and the non-face images, we want to find the winning HAR features. So which HAR features align with a face, and then on the reverse for non HAR features, we want to see which HAR features don't match. So like you're doing the reverse. You want to find HAR features that like do the anti-match, and then eventually, if you do enough reps, then you can kind of understand the HAR feature that determines a face versus not a face. So this is how it works. So we have, if we go back to this, you have a bunch of faces and a bunch of non-faces. So the way the algorithm actually works is, I'm actually going to come out of here for now. And can I zoom in? No, this is big enough though. So we have to test every HAR feature. Okay, that's pretty much it. There's only 5, but of course we can scale the size. So what we want to do is, you literally want to start here and check, 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 and then go down. Check, 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 of course. And do this across the entire thing. And then again, do it with a smaller one. Check, 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 blah, blah, blah. And then go to the second HAR feature, and the third, and the fourth, and fifth. And you keep doing this on every single image until you can find which ones actually match a face. So after, like I said, every type of HAR feature, every size of HAR feature, and every location. Qazi, there's a lot of background noise.
My bad.
So what was that? There's and every location of every image, okay? And each HAR feature, after it goes through the whole thing, it'll give you a number. And this number tells you whether it is a face or not a face, like what this HAR feature will say. So after this HAR feature goes through this entire image, okay? Or let's make it a little bit bigger, like there. So this is the good matching one. So after this goes through the entire image, each of these spots, it's going to get a number. So the way it does this number is, it takes all of the pixels in the black and adds them up to one number, then takes all the pixels in the white, this box, adds them up into one number. Again, grayscale is useful because we only have to deal with one number instead of RGB. And from there, you have a white number and a black number, then you just minus them to get the difference. Like, how far away are these numbers from each other? Like, if this was 0 and this was 100, then the difference would be 100. Or if this was 20, this was 70, the difference would be 50. They're 50 apart from each other. So this would be a 50, and we could say, okay, this match is 50. So this HAR feature in this location on this image has the number 50, and then we give it a threshold of saying, okay, if it's 50 or higher, say it matches good for a face. If it's 50 or lower, then say it's not good for a face. And so that's what we do. So you say, okay, this HAR feature goes all the way through, and here, and then at the end, it gets a final number for itself. And then you can say at the end of this, you're like, okay, this HAR feature in this location was really good. Let's keep this. Okay, this is level 1. This was the best performing HAR feature. Let's keep this because it was the highest. Like maybe it was like closer to 100 or something. And then after you do that, that was just one Haar feature on one image. You'd have to do this on every single image to find it, because it would also find the same kind of pattern on other people's faces, because their eyes are going to be dark and their cheeks are going to be light too, because that's what a face is. And then after that, you could be like, okay, this is the winner. That's Cascade 1. That's level 1. So whichever Haar feature matches the training images closest is our first winner. So if you go back here, it matched this one, like her eyes are darker than her cheeks. Then you could say, okay, that's a match. That's the first winner. Then we would go to the second one and go here and then see that this is another good match because the light nose plus the dark eyes. And we would do that too. But of course, you would have to iterate through the whole thing. And then, of course, all the different sizes too. You'd even go like tiny on every single image and all the background images too. But that's how that works. And eventually at the end, because if you take this black segment, add it to this black segment, and then subtract it from this white segment, you get a number at the end again. And then if it's above 50 or closer to 100, that's the idea. Then you can say, okay, this is a pretty good match, versus here where it would be like not a very good match. And you just do this over and over again, and you want to get like 1,000 Haar features that match. Right now, we're only looking at 2, but you want to do this over and over again. That's why computers are so powerful. And that's how you actually train the Cascade object detector, or in our case, a face detector, but you can detect any object depending on this, on the training data. So that's how that works. You have to test every Haar feature. And then after that, after you've gotten 1,000 winner Haar features, you can take that and then put it all together into a big machine learning algorithm for face detection. So that's what this diagram here is. So step 3, this is the cascade, which is just a chain of Haar features. A chain of Haar features. This was the first best match. This was second best, third best, fourth best, all the way up to 1,000th best. And you would go through in order. And if a picture passes all 1,000, then you can definitively say, hey, this is a face. If it only passes 900, it doesn't get to 1,000, you'd be like, it's not good enough to be a face. So that's the kind of the mark there. That's how that would work. So you take all the images that are faces, all the images that are not faces, then you train it with these Haar features. You find the 1,000, or it can be any number. Is you can kind of decide like when it's close enough. But you choose, let's just say 1,000 winner Haar features in order. And then we can chain them together into our face detector, which is called a cascade classifier, because you cascade from stage 1 to stage 2 to stage 3, all the way down to stage 1,000. And then that is stored as an XML file, which is exactly the data that is stored in here. So in here, it probably has 1,000 of these little things. So this here is one Haar feature. Could be one Haar feature. Like from this tag to this tag is one single Haar feature. That's the idea, okay? And then all these numbers are actually the Haar feature we are looking at. It has the brightness and the color and the location and the size of it. And you would go through, and then of course there's like 1,000. So you just fish the image through here, and then it looks for every single thing in the image until it finds faces. So that's why it's called a cascade classifier, or a Haar cascade, because using Haar figures, and then you're cascading down all the matches to Haar figures until you find a face. Okay, so that's the explanation of how it actually works. One final thing I want to do is the way it actually, well, actually, let me continue on in the slides.
Can you full screen it, please?
Yeah. So the nice thing about that is openCV does the hard work for us, okay? openCV provides all the pre-trained classifier data that has the chain of Haar features that best match a frontal face, which is exactly what we downloaded. Remember when we were at the GitHub, I said download Haar Cascade frontal face default. They have all of that data for us. They trained it already, and they have that data. And then from there, then after it's classified, we can just pass a sliding window. So a sliding window is just a window over the image or the current frame or whatever, and pump it into this classifier and run it through all 1,000 Haar cascades. And if it makes it past all 1,000, it's a face. If it only gets to 999, it's not a face. That's the threshold. And so yeah, if it gets all the way to the end, it's a face. But if it doesn't, then it's not. So that's why it's called a cascade, because you're like funneling down into what a face actually is. One last thing, let me just explain how that actually works. So what we would be doing is you would have like a sliding window. So you would have, or let me make this full screen. Or actually, I can actually just add a square, can't I? Shape. Nice. So let's just say we have a square here.
Good question by Evil Namekian. He said, is it possible to use face detection into a Flask application?
Absolutely. Yeah. I've never
Okay.
done it personally, but I mean, yeah, you can tie this into web development. You can
Awesome.
take this and then you can somehow call the openCV code in your Flask application. I mean, you could use Flask to like house something or house a web page, but you would need some way to get the openCV code running on your Flask. But it's definitely possible. Django might be better, but Flask might be cleaner. But look into it. But it's definitely possible. Just
Got it.
check it
Beautiful.
out. That's homework for
Beautiful.
you. But the way this works is you would take this little square, pass it through all 1,000 hars. It's like, oh no, this is not a face, 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 not a face. And this is so tiny, this would be not a face the entire time. And eventually then you would check a little bit bigger. Not a face, not a face, not a face, not a face. But eventually when you got this big, you'd be like, okay, not a face, not a face. Matches 900, blah blah blah, matches 950, not quite 1,000 yet, matches 950, but 950, boom, and then boom, it matches 1,000, and then that's when you get the face. So that's how it would work. And then it says ding ding ding, that's a face. And if there's multiple faces, then it'll find all of them in the current frame. And that's kind of the full algorithm of how the face detection actually works in practice, and actually like through and through with the math and numbers. Okay, so now I want to show you the final thing.
Romano, one interesting thing, Romano says you can adjust the sensitivity of face detection, and he basically says that that face classifier detect multi-scale thing you have, the last argument is actually for sensitivity. So you can actually
Yeah.
change the sensitivity you're looking for.
Yeah, you can go here, detect multi-scale. So you will have all of these parameters. You can do min neighbors, scale factor. So you can say like, okay, how many faces can be close to each other? Like, do the faces have to be far away? You know how we're getting random little squares here and there? You can say, oh, if there's a little square next to a big square, prioritize that big square and just omit those little squares to kind of clean it up. So you can kind of fine tune it. That's the nature of algorithms. You want to fine tune things until they're working nicely. But you just want to get it really close to working effectively. And of course, there's always the trade-off of speed and accuracy. That's always the case. That's just how the universe works. There's always going to be that trade-off. So, but yes, you are correct. Go check it out. You can play with all of these things. Like scale factor is 1.1 by default. Min neighbors is 3, and it explains what all these things do. And there's even other things like set image that I didn't go over. There's a bunch. I mean, it would take forever to go over everything. But definitely look at the documentation for openCV. But good catch. That is correct. Now let's go to this video. So this is actually Haar code visualization happening live. So everything I just explained and everything we just coded, this is what's happening. After the Haar code is trained, this is actually how the algorithm goes forward, okay? So let's start here. We have a lady here. And as you can see, like I said, the window will go across, right? And as you can see, whenever the current red square will run through a bunch of Haar features. So you can see it's spamming a bunch, and it's saying, okay, all those 1,000 Haar features within this red square, did this red square pass through all those Haar features? Yes or no? And it's saying no, 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 because it's not a face. Obviously, the face is down here. So it's saying, okay, is this box's face? No. Is this a face? No. Is this a face? No. Is this a face? No. By running through all of these crazy Haar features for each of these red boxes. That's why it's going so freaking fast. And it'll keep doing this for every face at every size until it finds the face. So let's just speed this up. And we're getting close. So as you can see, the stage, look, see it says 100% match here. Features 16 of 135. It's matching. There's 135 instead of 1,000 in this case. And you can see that this is what makes up a face. So you can see the match is pretty close.
Oh,
There's
wow.
22 stages. So see how it's seeing these red squares are a match? And then at the end, it probably averages all those red squares to find the actual face. And that's where those tweaking things, that's where those tweaking numbers come into play, because you can be like, okay, if all these squares are so close together, you can kind of approximate and just make it one square. Instead of 6 faces, that's the same face, just be like, nah, this is just one face with a bunch of square matches.
Dang.
So this
that
is
cool.
It happening in real time. And of course, if there's multiple faces, then it'll catch all of us.
People want to see the video. They're like, can you share the link of the video? Maybe you can just show
I'll post
the
it all
URL.
in the description. Yeah,
just no, but hit escape for now, so you can show the URL. And hold on, give me 1 second. Just show the URL, and so you guys can pause.
Just search this up. Anchor Divikar Haar Cascade visualization.
Yep, there you go. And you guys can also just type in the URL at the top. There you go.
Yeah. And that's really it, you guys. So that's the entire algorithm. You guys coded it up. You guys followed along with how it actually works mathematically, why it works, and how effective it works, and the efficiency and all that, and the trade-offs. And then also the extensions of it. Like you could do actually start like recognizing people. Like we could distinguish like Jeff Bezos from Elon Musk, or you could distinguish Pepsi can from Coke cans and stuff like that. If you do it enough, depends how much you want to train the data. Train the algorithm, how much data you want to do it. But as you can see, this is getting pretty, see how it got bigger? The red square is getting bigger because it's a sliding window algorithm, which is how most of, like self-driving cars, same stuff. It's very, very similar kind of idea. And that's really it, you guys. So it's getting close to the end here, and boom, there. At the end, it got all the boxes, and it approximated that is the face in the image.
Dude, I love that all of that is happening in literally milliseconds. Like that to me is insane. Can you open up the webcam again? Like I want to just see it happening in real time. That is crazy.
Yeah, I did omit one optimization, so I didn't get into the nitty-gritty math. I'm just explaining the general idea because the math is really simple once you, like if you know 1 + 1, you'll understand the math. I just didn't bother because it gets really in depth. If you want to read it, you can read the paper. I'll link that in the description too, but let's go back to the code, and then you can actually see it happening with the
cam for this one. So you might have to go at the top and change the MP4.
Yeah. You're right. To 0. Save that and run this and get that going. And Qazi, text me a picture.
There we go.
To my phone because I'm gonna pull up on my phone. I'm gonna hold it up.
Send
so that
you.
We can get 2 faces in the webcam.
Oh, I see. Okay, I'll send it to your Slack right now.
Got it.
Okay, cool. So
this is working in real time. Every single frame, it's doing the sliding window thing all the way across the entire thing, and it's doing the entire Haar cascade of all the Haar features that it was trained to within each of these squares until it finds this square at this size and finds my face. And it's doing that in real time just because the computer is so dang fast. So,
all right, about to send you. I'm having trouble actually finding.
I got different ones, so we can actually. So real time, we can.
Oh wow!
Get my face and both of our faces. It's kind of not getting Qazi, but see.
There we go. It got me. It got me once you went close.
Those squares. Yeah,
dude, it is looping through in real time. That is insane. It is literally looping through in real time.
Every frame, every size square across the entire image with all the thousands of Haar functions, and it's just like number crunching, fast enough. That's all it is.
Wow.
So it's really cool, and you gain an appreciation once you understand how it works.
Aaron, this is how we gotta demo it next time. We gotta just have like you holding like 3 phones, one with your foot. And then just like showing the 3 phones in your face at the same time. That's like mind blowing.
One issue is going sideways doesn't work, so it's not super robust, but you can do that. There's also side profile, like there's different, like this looks different than a frontal, but you could like combine a frontal. You could combine a frontal machine learning algorithm with a side. You can be like, oh, if it matches either of them, then detect it. Then you can be like, okay, this, or even a back head. You could even be like, okay, if it matches anything, and of course like different hairstyles, mine might be different than a girl or a bald guy, but I mean eventually you could really detect anything. And
damn,
that's really it, you guys. Face detection with openCV and Python with the entire theory and math behind it, so you guys understand it through and through. Hope you guys had your curiosity spiked, and maybe you're inspired to go learn how to do self-driving cars and work at Tesla, because that's what I want to do one day. Yeah.
That is so exciting. That was awesome, dude. Thank you so much for that demonstration. Guys, if you enjoyed this so far, first of all, drop it in the comments and like let us know if you enjoyed this. And also go ahead and smash that like button, because if you enjoyed this, chances are somebody else will get value out of it. Somebody else will also enjoy it. All you got to do is smash that like button to get this video out to as many people as possible. And if you haven't already, subscribed to the channel.
Yeah. And one last thing, I just want to mention again that if you do like coding and you enjoyed this and you are interested in doing this kind of stuff for a living, we do have courses here at Clever Programmer. That's what we do. That's why we exist. We help people make a living with coding, whether it be freelance or landing full-time jobs or tutoring or coaching coding to like high schoolers and other people, whatever it is you want. We are offering that, so the link is in the description to check that out if you're interested in pursuing that and being serious about it. And as a bonus for anybody who's watching this live stream, that course is taught primarily by Qazi and Jacob, the other Python instructors. But I also have my own entire Python course at Clever Programmer that's worth $197, where I teach the same style, my same bad jokes. But basically what I do is I go to Upwork, a freelancing platform, find jobs that are actually paying more money than the course is worth. Then I code the project up, or a portion of the project. That's it. I just code it and I teach you step by step the same way, the same thoroughness as I did here. Like everything, there's like no loop, there's no room for like misunderstanding. Everything's clear, and I teach you all of that in my Aaron style fashion. And we were gonna throw that in the 197 course, my course, because we actually don't. I don't think we've launched it in a while. I don't know if we'll launch it again, but we're gonna give it as a bonus to anybody who joins the Profit.
If they join it, if you join it today, we're gonna give that to you as a bonus. Yeah.
Because
if you
have
join
to manually enroll you. So if you purchase today, we'll manually go in and give you my 197 course for free. But today only, because today is the live stream day. So
And if you
attended live, that's your bonus.
If you guys join right now, you also get one call with Aaron, one-on-one. Okay, so if you actually join within the next like 15 minutes. So I just want to because sometimes what happens is people just need a little push and a little sense of urgency. And so let this be that push, because look, if you're serious, you want to turn this into a career and not just a hobby, something where you learn these skills and then actually also can use to go out and make an income. In the next 15 minutes, if you join Profit with Python, which is right over here on this screen, if you join this program, you are going to also get Automate with Python, which is a course with Aaron. So
I'm gonna teach web scraping, teach how to send text messages.
It's awesome. So basically literally he finds jobs from Upwork. Each job is worth over $500 to $3,000 each. And then he codes it and he shows you exactly how to do it. So not only do you know how to get those jobs, but how to get paid for them and then build them. So that's huge. So you'll get that as a bonus. And if you join in the next 15 minutes, you'll also get a one-on-one call with Aaron. All right. So if you're here and you're serious about this, join it. All right. Join Profit with Python.
Yeah, I even code up an app. I totally forgot about this, but there's an app in my course where we code up an app that literally tracks the International Space Station. So we use an API to get its coordinates and everything, and we have a map and we superimpose some little spaceship thing on the map and we can track it in real time. So instead of face tracking, we're ISS tracking on a globe in real time. So
that project is sick.
Yeah, it's sick. It's not even. It's just as.
Do you wanna, Aaron? Do you wanna take some time and pull up some of the projects? Either if we have a sales page or we have the actual course, and maybe find
the course would work, because I don't know where the sales page is, and the projects are not downloaded on I got a new laptop, so
that's all good. Just go to the course and let's see what type of projects we're actually building, so we can show them the inside of the course. Would you guys want to take a look at inside of the course that Aaron has built? It's called Automate with Python. Let us know in the chats, but he's going to be pulling it up right now.
Yeah, and so, you can join just that one for 197 if you want to, but I would encourage you jump into Profit with Python. Because you get this one free, and then also you get live calls with Jacob. I'm not actually hosting live calls. I prefer just to teach like this, I guess. I don't do weekly live calls, except for anybody who joins, and we can get on a one-on-one call. But
all right, I'm gonna keep answering the questions while and engaging with people while you pull it up. So Samrat says, you guys are doing amazing. Your tutorials are better than some paid ones. Love and respect. Thank you so much. Really appreciate you. Seriously, our free stuff, we try to make it as value packed as possible. And in our paid programs, the reason why they're always premium and priced so high is because so that we can give you that one-on-one and then the group coaching and help you actually land clients. Because if we just had everybody in there, it's really hard to help everybody in a personalized setting, right? We can't get on a call with the 300 people that are on this live stream, even though we would love to. but we really want to help you in your career. And so if you guys join, then you guys get on group coaching calls. And if you join in the next 15 minutes, you get a call with, of course, Aaron as well. So,
yeah. So this is the course. This is Profit with Python. Let me just give you a quick run through of this really quick with Jacob and Qazi. They teach this. They teach a lot of web development and like how to actually freelance and actually make an income from coding. Like Qazi was able to scale to 6 figures within 1 or 2 years of him learning to code, which is phenomenal. I never personally reached that level. I ended up doing this before reaching that. But so this is here. There's 15 modules in this course. You can check it out in the link in the description. Nice. Oh, there's also Slack and Facebook communities for it. So there's always other students to help you, and you can collaborate and talk within there. And then let me go show you the Automate with Python. So this is my course and some cool projects in here. So right here, how to automate stuff with Python. So here, same layout. We have everything here, and it's a little bit shorter course, but it's just as cool, just as fun. And let me just jump to the space station one, because why not? There.
Like each module,
the space station.
Got it. And also just make sure you go through the modules and like just highlight like each project and maybe how much it's worth, you know? So like the module name. And
I don't remember
like
the exact prices, but I know they're all worth the price of the course, so 200 or more. So I don't remember the exact, but this is a web scraping one. So somebody just wanted to web scrape some
and this is probably worth like $300 or something along those lines from Upwork. And then you have another web scraping one right underneath it, which is the PDF one.
Yeah. So there's a couple. I think this was teaching one, and then this was actually an Upwork one. So it's just like scraping PDFs from a list of websites. So it's like, hey, go to twitter.com and google.com and give me a list of all the PDF files hosted on these sites. And that's really all it is. You're just scraping all of it. I teach you everything there. Regex allows you to search for things in text. Email automation. So this is one because a lot of small businesses want to be able to like broadcast emails to potential customers and whatnot. So a lot of cool little projects there. Same thing with text automation. A lot of small businesses want people to be able to like text people for information or customers. System administration. So system admin stuff like auto copying files, auto editing files, bulk logs, stuff like that. Very important for big enterprise stuff. These are the fundamentals you're going to want to learn. And it's all fun. Like I have a lot of cool projects in here, and it's not boring like a lot of other courses. That's against my against my beliefs. And then this one, there's some Django, a little bit of Django stuff and APIs. And this is where we build the space station. So I'll just demo that really quick. And all the modules here on the left. And we'll go here. And let's just show it. I don't know if you can hear it, but all right, where's the...
But we can definitely see your screen.
There we go. So if you can see, right there.
Nice. And what is this doing?
It's tracking the International Space Station in live.
Guys, it's literally NASA, right?
Yeah, like it scrapes the NASA API.
Guys, it's using NASA
where
API and finding all the space stations and actually like showing it to you. That is insane.
Yeah. There we go. See, it's blinking for a bit. So that's where it was currently when I was making the video. And then it goes in like a sine wave across the globe. Let's keep going. So little sneak peek of stuff. Get this bonus with Profit with Python.
Yeah.
And yeah, just check it out if you want to do this stuff for a living, or the guys you want to be talking to. But
yep. So awesome. You guys got what it's going to be in there. It's super value packed. Going to show you how to make an income. Again, if you join in the next 15 minutes, you get the call with Aaron. If you guys join by today, you're going to get Automate with Python as a bonus that comes with it. And outside of that, you should just join Profit with Python anyway, because we're going to teach you Python and we're going to teach you how to make an income with it. With that said, guys, anything else you want to add at the end, Aaron?
Nope. Only about 10 minutes left though, because I can't handle too many students. So only 10 minutes left for the one-on-one call with me. Going now. Next 10 minutes and then 5 minutes later. Other than
Yep.
that, is there any questions in the comments? Because I haven't even been looking at the live stream. I've just been talking to my camera,
So
my laptop. And you,
Elijah says, I bought the
yeah,
PWP course the other day. Can I get the
nice.
Automate course? So because
Yeah, absolutely.
Elijah, yeah, sure,
Yeah,
he's on this live stream, right? He
yeah,
bought the
absolutely.
course the other day. So let's actually just enroll him into Automate. Even though it's a $197 course, what we're gonna do for you, Elijah, is we're gonna, as a thank you to joining and being on this live stream, we're actually gonna enroll you manually into Automate with Python, so you can have access to that entire course.
Yeah, man. Just have him post. Well, how can he contact us? Because we need his email.
Support and also
We
Slack,
need his email. Yeah,
Slack,
yeah,
and
Slack.
also
Oh, because
support.
he's in the course. Duh.
Yeah.
Got it. Yep. Just give us just contact us and we'll get that to you today. Any other questions, Kazi, in the chat?
So actually, I found Elijah. He's actually in Profit with JavaScript, I think, and I can actually see him in Slack as one of the people. We have lots of members, you guys. So we have tons of members. We have over like 1,300 members just in our JavaScript course, and we have over
Yeah.
2,500 members in our Python. And here is Aaron,
Yeah.
right
Oh
over
yeah. If you
here.
want to check out the JavaScript course, that's
Yeah.
this too. If you're
So
interested in JavaScript, we
let
have
me
this as
actually
well.
move this. Cool. So right there is Aaron, and then you guys saw Elijah. So yeah, just hit us up from Slack, and then we'll be able to help you, no problem. Okay. And Logan also says. So Logan says, let's see, Logan. Let me do this.
Logan
Logan
Federley?
says, could I also get
Yeah,
that
what's up,
course?
dude?
I'd really appreciate if those topics are the same ones that I'm going to be making proposals for. Yeah, Logan, absolutely. You're in Profitable Shortcut, so for sure we're gonna add that on as a
Yeah,
bonus
he's
for
killing
you.
it. Yep.
Yeah. Logan is on our most premium program, so he's working directly with me, and we're getting on even one-on-one group coaching calls. So yeah, for sure, we're going to add that in for you.
All right. So probably like 6 minutes left. If anybody, I don't know how many came through, but I'll
Yep.
get on one-on-one calls with anybody who joins.
Yep.
Um,
Awesome. I think that's it,
or whatever
guys.
you want.
Thank you. Hopefully, this gave you value and taught you guys something new. This was a mind-blowing experience for me. Hopefully, it was also a mind-blowing experience for you. With that said, guys, we love your face. This is Qazi, and
This is Aaron. What's up? You see me?
yep. And that's it. With that said, we'll see you guys in the next video. Peace out, guys. Bye.